Okay, so let us quickly get over all the 13 lectures. So lecture 1, if you remember, was preliminaries and was introduction to blockchain. I played two riddles as well. And we said blockchain is basically a block connected together. And what is in a block is a number of transactions. And they are so they are put like in a block so that they become immutable, mean nobody can go and change any transaction. And how it is achieved? Through a distributed ledger that every node has a copy and the hash of the block, and this block basically once it computes its hash, it also takes as input hash of the previous block to make sure that they all get connected into a chain. And then we talked about transactions, that because a blockchain is not only about Bitcoin or cryptocurrency, but any valuable thing if it is changing state, possession or ownership, and if it is to be recorded, then you can use the blockchain technology to do that. And so there could be many applications, maybe relating to business or social or academic transactions. And ledger is just a record which records a transaction. A serial number, what is the transaction? If like something has happened to that possession or an asset, you record that, and that you record the timestamp. And then we also talked about, because blockchain, and once an asset is changing value, there may be a law that is governing that change in the status. So the law is basically gets into a legal contract, or it may just be a business logic, gets into the code. So legal contract has the value. And then we talked about that blockchain basically kind of hates the central authority because it rents and everything has to go through that. It results into inefficiencies, corruption. So three aspects of blockchain. One is it is timestamp append-only log. It is then through the hashing you make it auditable database, and then there is a consensus protocol which is very important, that because there is no central controller to check the validity of a transaction, so everybody has to check the validity of the transaction. So the most challenging part which the blockchain solves is the consensus, that how in a distributed system you come to a consensus. Everybody kind of agrees independent of what other people are actually doing, and it is done through proof of work, proof of stake, or proof of authority. And then I also mentioned that in 2021 a lot of focus, like people believe that blockchain technology has taken the central stage, may it be machine readable legislation, decentralized finance, non-fungible assets or tokens, and decentralized identity. So kind of we have covered all of this. And then this is what I said the course learning outcome for myself and for the class, and we said it is to understand how the blockchain system works, and welcome Sanjeev, why it is used, and to know when and why blockchain should be used and in which context. And we talked about applications, and the most important aspect which I kept at a high level of cognition was that you should be able to design an application and taking that into blockchain, the logic, designing the logic and coming up with the idea. And then we took, this is the distribution of the grading, like 20% assignment. So there are 7 assignments which you have actually done. There was a midterm and going to be a final exam, and the final paper which you will also be presenting. So this is just coming from there, and then showing you how a blockchain actually looks like in Bitcoin. So showing you this blockchain, the basically hash of the block, and who is the miner, what is the size of the data, and at what time the block was created, so that on average every 10 minutes a new block is created. And then showing you a detail of a block, and especially every block has a number of transactions. So for example, this block 3000 transaction. And then talking about the from where it started, which is Satoshi Nakamoto paper, and his email rather, where he said that I have been working on a new electronic cash system that is fully peer-to-peer with no third party. We discussed his paper, and we said this is the course outline as well. All the figures in the paper which talks about public, private, chain, hashing, transactions, Merkle trees, and so all this and how you verify a Merkle tree. So definitely there will be a question in the exam about the Merkle tree. So just get ready yourself, just that how to basically do the verification given a transaction and some of the hashes and the Merkle root. So you got to compute that. So there'll be a question about it. So then in second lecture we started learning about why cryptocurrency has value, because people don't understand, and so we went through that what is the role of money in the society, and then linking it with the cryptocurrency, that it is just a social consensus. If people start giving value to something, it becomes valuable. And so we spend time learning about that money is a medium of exchange, a store value, a unit of account. If something has these three properties, we say that it is money. And so if it is not a medium of exchange, for example, cryptocurrency yet is not a medium of exchange, so people usually call it a digital asset rather than calling it a digital currency. And we went through the whole history, talking about two groups, one believing that barter started the money, and the other believing that it is the government who takes taxes and lend money to people. And then we saw that no matter what currency you are dealing with, every currency goes down. So every currency goes down, including dollars. So it really should not, people must not keep their money in fiat currency, no matter whether you are keeping it in dollars. Dollar is also losing its value. So it is always good to invest your money into real things. And we saw that crypto market capitalization increasing. Now actually it is now $3 trillion. And then going through the hash and also showing you the Merkle root, that the Merkle root is important, and how you get to a Merkle root, and difficulty, that how the algorithm sets difficulty, so that it usually takes almost 10 minutes on average for a block to be created. And then going through these blocks and इसको किधर है वो? ये नहीं है, उसी से चलेगा, दोबारा से उधर चलो। ये तुम्हारी पावर आ रही है इसमें? ये लग रहा है पावर आ ही नहीं रही है इसमें। नहीं लगा है। नहीं, इधर लगाओ सर। अब लगा। उसको लेकर एप्लीकेशंस। बस सही है, छोड़ दे। नेटवर्क वाला कौन है यहाँ पे? नेटवर्क ब्लॉक है। अरे फिर नहीं लगा हुआ, इसको दोबारा चेक करो। बस ठीक है, छोड़ दो छोड़ दो। हाँ अरुण किधर हो? आज ये कनेक्ट नहीं हो रहा है इससे ना। About the consensus, that in blockchain the most difficult problem that was solved was the consensus. In a distributed system, the consensus is the most difficult problem to be solved, as it is a Byzantine general problem where we discuss about that. So in lecture number 3, then we started discussing different components of blockchain, which was cryptographic hash function, and we also discussed an application. And hash function is so central to blockchain. Okay? So we saw that why it is so central to blockchain and what is the algorithm. So we did a lot of exercise to make sure that we have very good understanding of hash function, because अच्छा screen share नहीं भी, sorry. So definitely, again, I will be asking a question in the exam about the hash function as well. So Merkle tree, hash functions, because they are very core and fundamental. So please make sure that you again do some practice. So then we talked about the supply chain management and the IBM primarily getting into this area, and we in detail discuss this, which is drive end-to-end visibility for the vehicle that are rolling out of the manufacturer and going to the customer through retailers and traveling on sea. And so we covered that. Then I discussed this paper as well. So there definitely will be a design problem where I would ask you to design, giving you a problem and asking you. That will be the major part of the paper, designing. So please go over these slides where a detailed design is shown, including the transaction as well, that what the transaction and how the different transactions are happening once something is moving in a blockchain network. So going from for the supplier to yarn manufacturing to fabric manufacturing to apparel manufacturing. So thinking about this, that how you basically put it in a blockchain, what gets as a transaction, and how you collect, and how many transactions are to be collected to make a block, what makes sense. Okay, so this is, and obviously deciding about whether you want to do it as a permissionless or a permission blockchain. So that is also a big decision. You need to take a permissionless where you want anybody to become part of the network. It is for general public. So anything which is for the general public, like NFTs, like cryptocurrencies, because it is for everybody to basically just become part of it, then you make it permissionless. But if it is not specific to everybody, okay, so it is preferred that you make it permission blockchain. Okay, so just remember this difference. So in lecture number 4, we studied the digital signature, and remember that hashing. After learning hashing, I wanted you to learn about how you generate public private keys and then how to sign a document with your digital signature. And then we said similarly you have a digital identity, which primarily is created a digital wallet, precisely like having a public and private key. And so we studied digital signatures, We talked about symmetric encryption, asymmetric encryption. So in a blockchain, once you are signing, only then you use asymmetric encryption. Otherwise, if you have documents and you want to encrypt them, it is many times more computationally intensive to do asymmetric encryption. So people do symmetric encryption, and they exchange the keys using your public-private key. So using asymmetric encryption, keys are exchanged. So both the parties have the shared secret, and then you just do the symmetric encryption. If you are, let's say, on Facebook, you are uploading an image, or your just pictures and your messages, so they all get encrypted using symmetric encryption, okay? Not asymmetric. And you have seen that if you have a size of the message greater than a number, asymmetric key would not work. So you have to break it down and do other things. So just remember symmetric versus asymmetric encryption. And we spend a lot of time, because again, it is core to blockchain, which is asymmetric encryption, that how it works. So we did exercises that this is how asymmetric encryption works, which is about that public-private key pairs, and how you so two ways of doing asymmetric encryption. Either you encrypt it using your private key. It is only once you want to assert that this is who are actually doing the transaction, okay? So for example, if I am sending money to somebody, I got to assert my signature with my private key. So person who is receiving it will have my public key to verify. So everybody has a public key, and he would verify, yes, it is me who has actually transact some money to somebody's public account. On the other hand, if I am sending a message to somebody, so I will use his public key to encrypt, so that only he can open that using his private key. Nobody else can actually open it, because he has his private key. So if you want that message, okay, so I may just ask this question in the exam as well. If you have a message, okay, which you want everybody to know, everybody to verify it is coming from you, you encrypt it with your your private key. And if you have a message which you want only that person for whom the message is meant, so you encrypt it with his public key, okay? So we spend a lot of time on this, asserting a digital signature. A digital signature will only affirm that yes, you have actually asserted, and anybody can verify. Anybody having a public key can verify. So this is again very fundamental to blockchain, okay? So very fundamental to blockchain, asserting digital signature, having our data. So you may expect a question on this as well, because this is very fundamental. I want everybody to practice, to know that the differences and how to affirm a digital signature, where you are not hiding the data. Data goes in open. You are not hiding the data. You are just taking its hash, and you are encrypting the hash, and then appending it at the end of the. I'll send you a sample paper as well, okay? And then you assert, and the person who is verifying, he take the data again, which is in open, and again computes a hash, and then decrypt and check the two hashes. If they are the same, they say yes, it is a valid signature. So this is how basically they affirm. So we went through the RSA algorithm. I did several examples.
That text everybody could see, but verification would be done only if the person whose key was.
In blockchain, everybody verifies. Okay, yes, इसी ने इसको भेजा है, right? So everybody verifies, so that everybody has to make that entry into the blockchain ledger. Yes, this person has sent this much money or value to him, and it is actually this person who has done it. So because, and that is the reason that everybody has to verify. Okay?
The purpose is just verification, not hiding the actual.
Not hiding. It is just like a signature, like you sign on your check. The purpose is for the bank or anybody to know that it is you who has signed, because some value is getting transacted from your account to somebody else's account.
Sir, in case of like public kind of network, of course you have to go through consensus algorithm, and more than 50% should validate. But in case of private network, for example, in case of HEC's own environment,
Yes.
there would be some particular nodes would be verifying.
Yes. जी अभी मैं उसको I will review that too, ठीक है? So we will review that what happens in a permission blockchain, how the consensus is achieved, ठीक है? ये अभी हम इसको देखेंगे. So but I told you this is the magic. The magic is your message raised to the power your private key and taking modulo n and raised to the power your public key, and again taking modulo n will give you the message. So this is how you encrypt message raised to the power your private key modulo n. This is the encryption if you are encrypting it with the private key. If you are encrypting it with somebody's public key, so message raised to the power d modulo n. Okay, see the other person will do. So it's like a magical relationship between E and D, right? If somebody has E, then you can only decrypt it with a D. If somebody has D, you can only decrypt it with E. So it's a magical relationship, and that is used to do Diffie-Hellman key exchange as well. A Diffie-Hellman key exchange is that you have a G in which you share, which is just a plane, then you raise it to the power your private key and send. And the person take G raised to the power his private key and send. And then you take raised to the power your private key. So a G raised to the power his private key and your private key becomes a shared secret which nobody would able to figure out. And that is how a key is exchanged for symmetric encryption. Now both parties should have the same keys. For the symmetric encryption, both parties should have the same key. Then there are hundreds of ways of doing the symmetric encryption, which is very, very fast. Right? So we.
Is it only this Diffie-Hellman?
No, there are other as well.
They are interchangeable, for example, private and public key, because there are some other techniques that work one way.
जी look, this is ये देखें, ये जो है ना, this is your shared secret. Let's not even call it a private key. This is your secret. Okay, this is not a secret. So you have a G, you send the G to the other party. Okay, so both have G. This is your shared secret. It's a large number. So you take G raised to the power this large number. Okay, and the assumption is knowing G, nobody can actually get A, because you have to take 1 over A. It is eighth root of G, which is almost impossible for people to take. So this is this is your secret. You take this, send it here. G raised to the power, another number, which is a big number. And this is his secret, which you don't know. So the beauty is neither you know his secret, nor he knows your secret. And still you get a secret which is shared by two of you. So this is the algorithm which is used in almost every time internet you are on the Facebook or WhatsApp, and so that's how the keys are exchanged using a Diffie-Hellman key exchange algorithm, and then you basically do the transaction. This is TLS, which is transaction level security. So this is how the TLS works. Okay, so we then in lecture number 5 we started something very interesting about the transaction in Bitcoin, which shows its strength. Okay, and definitely a question will be on the UTX as well, UTX2 as well. Why it is so elegant? Because the traceability, like in cryptocurrency or in digital currency, if you want to call it a digital currency, the power of the digital currency is the currency will never go out of the system. Okay? If you have a cash you take out from the bank and you put it in a box, so it just goes away. Nobody can trace where the cash is. But a digital currency, the beauty of digital currency is that it is always in the system. It is only changing hands, because you can trace that this is how it was created. Even the state banks are coming with state bank digital currency. Okay? Even once the state bank have the digital currency, it will remain in the system. It will only be changing hands. Okay? It will remain in the system. So nobody can actually basically just take it out and goes away. Okay? So this is the power of the cryptocurrency, that you can just trace from where it got generated and where it went. So we covered that in a blockchain, what all the things you have, but primarily a transaction where you sign with your private key, you put the public key, which is the address of the person you are sending this money to, and you put the amount. Okay, and so we studied that in in Bitcoin, the Bitcoin would not add all the money you have in different UTXOs and give you a sum. Rather, it'll just keep it as it is. Whereas Ethereum would actually do the accounting for you. It says these are the number of ethers you have. So its elegance is in its simplicity, that Bitcoin is so simple, the design is so simple that he has not done anything. He said, okay, once the money is generated, so there is only one way for the money to be generated. And this is how it controls its inflation. Okay? So you cannot inflate the cryptocurrency at your will. It only gets inflated with a very, very specific method, that it started with 50 Bitcoin every 10 minutes. Now it is 6.25 Bitcoin every 10 minutes. So the only way you can get that money, only one person will get that money. Who would mine it? And if you want it, okay, either he would pay you for some services, or there are exchanges. You go to an exchange, give them dollars, and he will sell. So there is only one way for the cryptocurrency to be generated, and it is always in the ownership of the person who is mining. And if he does not want to sell, he does not want to sell. Okay? But if he is selling, he is selling. So you can only buy if somebody is selling. So from UTXO, we studied that you have UTXOs, and UTXOs, the algorithm by itself will find out that how many UTXOs of yours will be used to do a typical transaction if the transaction amount is more than the money you have in one UTXO. So here in this example, you want to send 1 Bitcoin to somebody, but you have 0.5 and 0.7. So these are the two UTXOs, so equal to 1.2. So 1 will be sent, and 0.2 you send it to yourself. So these UTXOs kind of goes away, and you generate 2 more UTXOs. Okay? So this is how and then we learned that in Bitcoin, it's very simple scripting language, scripting code. Script is where you run a line by line. So you don't need to compile a code, because once you compile a code, then you have to have a machine to run it. So Satoshi Nakamoto made it so simple to work that it is just a script, and script one instruction, and it is where you have a stack, and you just push, like very elegant. This is kind of an instruction which I covered the other day as well. You say 2, 3, add as 5 equal. So every instruction would result either true or false. Okay? So it says 2, push 2 on the stack, push 3 on the stack, then add means you want to do something. So add them together, so there is 5, and check if the answer is equal to 5. You say yes, so answer is true. It will return yes. This instruction is successfully got executed, this line of code, this script. So that is how the Bitcoin is very simple language, but it is very limited as well, because you cannot do any complex coding in the scripting language of Bitcoin. So people started realizing the limitation of Bitcoin, that you can only do very little things, which is primarily just sending some money from your UTXOs to another UTXO. So he made it very simple, because his purpose was only to transfer the Bitcoin from one UTXOs to another UTXOs. And then I showed you, because there are UTXOs, a lot of work is happening on analyzing. And we covered this where you can see that how many UTXOs have been older than 10 years, that people have not spent them. So these are UTXOs older than 10 years. And but there are people who are very quickly spending. They create and they spend, they create and they spend. Okay? So you can see these are called the way that you can hodl that, which is also point out significant events, and I'll not get into these. Then we covered digital identity. I said this is something again becoming very central to blockchain technology, where you have, and we talked about Estonia having digital identity. And this is perhaps the question which I also gave you in the midterm, that how you create a digital identity and how a verification is done on the digital identity. So then we learned about Ethereum. And Ethereum was that it basically everybody must have realized the limitation of the Bitcoin, which is just a very simple scripting code. So this guy decided to have a Turing complete language, and he said now you can actually code very complex logic, and that brings the concept of a smart contract, that something a valuable is changing hands or changing possessions. So there may be a very complex logic that governs that transaction. So that is it. If that there may be a very complex business logic that governs the transaction, whereas in Bitcoin there is no complex logic. It is just you are willing and you send. But if it is a house you are renting, okay, a car you are buying, okay, and there is a supply chain management, you got to make sure that certain conditions are met. It is certified by somebody who has inspected it. So there may be many complex conditions, and only then you want that transaction to happen. So then becomes the smart contract then becomes central to blockchain, and so he came up with a Turing complete language, Solidity, and you can code that in Solidity. Okay, so the Ethereum becomes like very popular because of this reason. Not only because it also has its own cryptocurrency, which is Ether, but then it is in so many applications. Okay, so these are the decentralized or distributed application, DApps. So there are many DApps which are based on Ethereum. You can download a copy of Ethereum and can develop your own DApps. So people started developing many different applications after the Ethereum. And remember, we learned about this concept of fee and a gas, because every computer will be executing a smart contract, so you got to leave some money to pay them. For storage, you have to pay more, and you can just say that this is the maximum amount I'll pay for my contract to run on every node in the network. So you set up the limits, and then we did some hands-on with Ethereum. We installed this MetaMask wallet, and then we also got requested Ropsten and few other sites to send some virtual ethers to your wallet, seeing that how the transaction happened. Then Ganache, I told you that this is basically a local Ethereum chain, and you can download the code and do your applications. And we did that. And then we said smart contract is as central to this. And basically, it has many applications. People believe that even the law will be coded as a programming language, because a law which deals with the contract is nothing but many if-else statements. And we kind of spend a lot of time learning about that, what legal contracts are. And then we also said that in any legal contract, there is some expression which you explicitly write. You say, these are the terms of the contract. But then there are others which you need not to write, okay? Because there are like broader spectrum where the government is responsible for some of the clauses in the contract. For example, if somebody dies eating something, you don't have to write that person must not die after eating this chocolate, because you know. So that's why people say that the government is in the room once you sign any contract, okay? So there are clauses, and you cannot write any clause which is basically in violation of the law of the land, because those will not be enforceable. So, and we talked about why the smart contracts are important in third world countries. So I would definitely ask you a question where you have to design a logic for a smart contract, okay? Just a flow chart for a smart contract, that this is a scenario, these are the conditions, okay? So I want you to just give me a logic that this is how you will design your smart contract, okay? So this is like a complex contract which has many options. So maybe a flow chart, a binary tree or decision tree like this. If this happens, then what you do, this happens, then what you do. So I would definitely ask you to do something like that. We then went and did an example of the second price auction, right? A second price auction was the second highest price will, the person who has second highest, the person who has the highest price will only pay the second highest price. Okay, and then I showed you the whole logic, the code, and I told you that though I understand not many have like programming experience, but still we went through the code, which is very simple to just read. It is just written like a story that the person who has the highest would get the rest. Everybody will be repaid of the money they have actually deposited, and then like lecture number 7 was digital signing a transaction and man in the middle attack. So we said it is also very key to especially permission blockchain, where every person has an identity. So you got to know everybody who is in the network. And to know everybody who is in the network, you got to give him an ID. And how do you give an ID? Using the PKI, which is public key infrastructure. So we sent first, we did this example that how you sign a digital certificate using your private key. So using your private key, I said, okay, this is a certificate. And we did this example. Then I also gave you an assignment to work, which is how you basically sign. So issuer basically, and then the person who is verifier or verifying, and how would he verify. So did this example, and then discuss that there is this problem, man in the middle attack, who could sit in between once you are exchanging keys, and then he may have a shared secret for you and the same shared secret for him. So once you start doing encryption, this guy would actually just get whatever you are sending, and though the other person is also getting the same message, but this is man in the middle attack, where, and we said that for handling man in the middle attack, so every transaction on the internet has to have an ID coming from a certification authority. A certification authority, then I showed you that about case and the certificate 509, and I showed you case from where we got our digital certificate. Okay, so we went through this, that if you see this sign, it means it is secure transactions, and we went through, and these are different certification authorities. And in lecture number 8, then we discussed fork. A fork is because it's a distributed network. Okay, if there is a disagreement, okay, half of the network is saying no, we want to go this way, half saying we go this way, then they go their own ways. Okay, so then they go their own ways. So a fork is created. A fork is created, and we spend learning about all the forks in Bitcoin. And
the problem of fork would arise in permissionless.
Only in permissionless blockchain.
In permission, you cannot do.
Yeah, you cannot. On permission, you don't. There is no need for you to fork. Yeah, you cannot. यानी कि आप कह रहे हैं कि they may say कि fork ना बने. Yeah. So they may just make sure कि fork ना बने. Fork होता ही है because decentralized है. There are so many. It's like in parties there is Muslim League Noon and Muslim League Q, and once they have disagreement, they go their own ways. Okay? So they create their own party, and they just, so it's almost like this. And maybe in the protocol you ensure that it will never fork, but the forking people are taking it normal, that they say, okay, the fork, if there is a fork, there is a fork. So we discuss about, so many forks that got created in these permissionless blockchain. Okay, there are forks in this, there are forks in Ethereum as well. Okay, Ethereum also has forks, and this is, and primarily then we discuss the consensus, why it is difficult, because you are solving a Byzantine general problem. G sir.
Sir, is it true that there is nothing absolutely decentralized? Because last year I was reading something about that. In Bitcoin also there are like 10,000 concession nodes. In Ethereum there are 15,000. So if the number of members they exceed this, that means there will be few which have this privilege of consenting, and there will be few which won't be having this privilege.
जी जी आप
There must be some core group behind Bitcoin, also behind Ethereum. They decide.
Let me respond to this. Once we say consensus, you don't tell that I have like consensus on this, because it's distributed. You don't need to tell that I have verified this. Okay, so you need not to tell anybody I verify. Once we say more than 50%, it does not mean that 50% there is voting and everybody is saying, oh, I agree, I disagree. No, it does not happen like this. Okay, what happens is they say that there is a proof of work. Okay, they say let's make this process very, very challenging for somebody to come up with a block. Okay, and you are right, there are only few people, like more than 50% of the blocks are generated by 3-4 entities. Okay, so they are the people who are kind of controlling, because they are making money, they have no issue but to do something which is very wrong. Okay, so everybody can actually mine, but again there are only pools and there are the many people who are part of the pool, but the other people are only just, once they create a block, they only go to verify yes with the noise and the hashing, and they prove, they say yes, and then they say okay it is a valid block, and they put it in their ledger, local copy. ठीक है, इसी तरह if I come, I have a paper, and what I do is I just start distributing you the copies. Okay, so you have a copy. Okay, now I say that this question, this value is not this, rather this value is this. Okay, and because and so this is I, and then that change I also communicate to everybody, and then you look at that change and you just put that change on your local copy. Okay, so you're not telling him that I have made this, have you made this? Okay, you're not doing that, you are only checking. So the consensus does not mean that there is a consensus among the class that this is a valid transaction. Absolutely not. Okay, this is the beauty, that consensus does not mean that you are taking vote. Consensus only means that somebody who has created a block, okay, you go and you check. For example, I say, oh, I have created a block, and I just give it to 5 people, and then 5 people goes, and through this whisper algorithm everybody gets a block, and once everybody checks and everybody finds out this is not a valid block, because the hash, which is so many leading zeros, and if you do the hash of whatever he has sent, it is not resulting into those many zeros. So you drop that, you say, oh, this is an invalid block, without asking the other person, oh, is this valid? You say, no, this is an invalid block, because so the consensus is a distributed consensus, not that you are actually going and asking. Okay?
Sir, in this proof of work, some of the nodes, they go through very extensive computation and they come up with a solved
Yes.
problem. What that solve? I mean, besides moving of that computation is not used anywhere.
That is not used. It is a wastage, but that's how he has made that problem. Not everybody should do it. Okay, he had made it so difficult. Okay, like few people can do it. Okay, anybody who does it the first, get the reward. Okay, and that's how he has protected and solved the double spend problem. Okay, that's how he has created the consensus. Okay, this is just amazing. If you think of it, like this is a consensus, like everybody is agreeing without asking other. Okay? And not everybody can spend that type of power and energy to create a block, and so that there are multiple blocks. So, and it is just a stroke of luck. Okay, it is not like 10 people or 5,000 people coming up with the block at the same time. So everybody gets confused, because the number of transactions in every block may be different, because it is up to the miner that which transaction he wants to keep. So he has made it so difficult that its probability of that the creation of that block happening in a time is only one person who could, it's not like 10 people just generating or 10,000 people just generating that block and creating confusion all over the place. So it's like amazingly beautiful. The way the consensus works is amazingly beautiful. Okay, and that's why blockchain is still working after so many years. More and more people are just investing their money, and so we discuss about proof of work, and many of these the cryptocurrencies, they use proof of work, but then there is a proof of stake as well. Okay? And the proof of stake is that if you have more stake, instead of wasting all the power, they said if total number of transactions are worth, let's say, $500, so you put $1,000. Okay? Because, and if you tell us wrong, your $1,000 will go to the network. Okay? So you put your stake in, and then we will agree. And now you say, yes, this is, and we will check. We say, yes, this is right. Okay? And after some, we will release that, and you get the reward. Okay? So the people said, why not to come up with something where people put, anybody who wants to verify put his stake, and if he's lying, then his money goes away. It gets into the network.
I mean, only rich people can.
Only rich people. Then the point was, then only rich people would.
Rich people will get more richer.
More richer, yes. So there is always pros and cons, and people were complaining like staking electricity of a country. A miner would just, the amount of electricity this mining is taking is even like an entire country, because people are just putting more and more and more power to be the winner. So people don't like it. They say, oh, you are wasting, polluting this, and so they are coming up with other ways of generating consensus in permissionless blockchain. Okay? So this is permissionless blockchain. And then we said, but if there are only few people and the transaction is happening among few people, then why to involve everybody in the world in that transaction? Why you want everybody in the world to put that transaction in the ledger? It does not make any sense. So people thought, let's come up with a permissioned blockchain, and anybody who has to be part of the network, you permit him. As a system administrator, you create a network, and you say, okay, you are part of the network. And here, so many people started investing because they thought this is even more valuable than perhaps permissionless blockchain, because here actual assets are changing hands. Actual assets are basically transacting. So this perhaps will have more value in time than perhaps the cryptocurrency, because this is real. So many big companies like IBM and Oracle and SAP and so all became part of this group, and they said, let's create something which is in open source and which is elegant. So this is perhaps, as I mentioned in the last class, this is very elegant, that how the framework, this whole framework works, how these certification authorities you create, how the client applications you have. Okay? So this is all very, very elegant, and the architecture. So I'll spend a little more time in this, and then I remember I did this complete design, that if we have universities and CASE and FAST and NUST, and they have decided that their students can take courses, CASE students can take course in FAST, and FAST students can take course in CASE, but FAST and NUST, but not CASE and NUST. Okay? And so you can just create a permissioned blockchain where every student has a client application, and if you want to register in FAST, you go and you invoke a smart contract. And smart contract will have logic, which it would see whether if there is a different fee structure, prerequisite requirement, a GPA requirement, or whatever FAST imposes on CASE students, that only then you can take, or CASE imposes on FAST students only then. The FAST then, so we did this complete example, and talking about especially this network where we have consortiums. If you remember that CASE was consortium. This consortium is CASE and FAST, and this was FAST and NUST, and the HEC creating this network. And so we discussed that. And this channel is between the CASE and FAST student, and this channel was for FAST and NUST students. So FAST is common. So FAST is common in these two. So the FAST, which is R2 node will have two ledgers and two smart contracts. One smart contract which works between CASE and FAST, and the other smart contract that works between FAST and NUST. So we spend a lot of time in discussing the design.
Two smart contracts will be run on same peer.
Yes, on the same peer, which will be maybe a registrar of FAST. This machine may be of the registrar of FAST, which is running two smart contract. Okay, so a student, which is CASE student, is invoking. He can only invoke this smart contract.
So this is a logical diagram, but what if actual scenario is there? Is it advisable that only one peer is running very
No, you can have more peers. It depends.
I mean,
See,
practical scenario, would it be network of peers because now?
yes.
Otherwise, this is a centralized concept. If only one peer is there.
नहीं देखिए, for example, this peer, you may have like multiple peers, and we'll come to this. You may have multiple peers in case and multiple peers in fast, but this in case, all the peers in case would have only one ledger and one smart contract. All the peers in fast, maybe their dean, maybe their vice chancellor, maybe okay if he wants to be involved. So then they will have two ledgers and two smart contracts. So this is how it will work. Definitely you can have more peers depending upon how you structure a problem, like a problem where we said the faculty members and the head of the departments, and there are 4 departments and their office of the dean, like the assignment I gave you, that you have to just create.
These deciding rules, like for example, case and fast would come, then smart contract 5 would be run, and if other 2 come, then this will be decided in HEC's admin, or who will decide that, okay, in this case, this will be run, in this case, this will be run?
Ji, this will be decided. For example, this application, A1, which is a case student has running on its smartphone, will only talk to this channel, okay? Can only talk to this peer, can only invoke this ledger, can only invoke this smart contract. This is at the, once you are configuring the whole network, you configure this like it, that this is the peer.
I'm asking that
Yes.
you configure this whole network, this HEC.
A system admin, he may be the guy, but in this example we said, HEC said, okay, you create a network, but I don't want to be involved. And HEC has given this responsibility to case. He said, okay, you case system admin, I don't have time, but I appreciate what you are doing. So this is a network you create, and you can add more universities, but you are the system admin. So here, remember we said HEC is R4, and HEC said, I'm not interested in just knowing who you are making peers and all of that. So you do this. So this is the guy who is doing this, which is a system admin in case, who is just configuring the whole thing. See?
Then this peer group was at the same time integrated with the smart contract 5 and 6.
Yes.
I mean, you had option of availing studies in 2 institutes. Whereas in a peer 1, that is case,
Yes.
as per this diagram, it doesn't appear that it has also the option of opting fast also.
No, look, this is the channel. This is the channel. On this channel, there is fast, this is case, and this is fast, 1 and 1. On this interface, case students, once they register, so this peer and this peer both needs to agree. Once both are agree, okay, the smart contract, and especially will go and understand that how this thing happens, but both got to agree. So once they agree and they affirm that yes, I have no problem, and says I have no problem, and then there will be a logic which is running in the client application which says if both agrees, then I send it to the orderer. Okay. So we spend a lot of time on this, and then lecture 9 was about NFTs and IPFS, and we learn about fungible, what is fungible, what is not fungible. And we said something which is replaceable is fungible, and you don't care that which copy you have. But if non-fungible is only there is one unique copy, and you say non-fungible, and then we said there's a lot of craziness in this sphere, like things are being sold at very, very high price. Okay, and yeah, it is very difficult to digest. It is very difficult to digest, right? You are right, but okay, so this is very difficult to digest because the thing is there, anybody can download, and it is not like a painting which is only in your house. It is just anybody can download the whole thing. So we know about 2.9 million, his first tweet. And similarly, somebody was saying auctioning the first SMS as well. And then this going for $69 million, and then this whole thing of crypto punks and the NFT market going up, and that how it gets into the blockchain, and then so how you create also. So we spend a lot of time learning about this. and trying to understand the rationale, though difficult to understand, as you said, but still we spend some time, like these are the punks, and which are basically a revolt against these set norms.
My 7 years old son can do better finding
Yes,
that.
yes. But this is, it is just like social consensus that people start giving.
I literally spent hours and hours exploring that. Like, seriously, is it?
It is real. Yeah, it is real. It is real. So then we also learned that they don't remember, storing something on Ether network is so expensive. So expensive, okay? Because then a copy will be saved on every machine on Ethereum network. So nobody wants to store, nobody wants to make data part of the content of a transaction in Ethereum network. So what they do is they put it on IPFS, okay? Which is just, they split the file into small pieces, and they just throw it on this network where there are many computers. And whosoever read it, it has a copy of that on its cache. So anybody who wants to get it, if there is already a copy, so we'll just get a copy. So this is the whole thing, and we discuss about this Gangnam Star and how many petabytes it has taken. So this is, so spend time on this. Lecture 10 was how to mint an NFT. So we went there, there's a marketplace, and anybody can register, and somebody in the class also registered his, I saw it was a picture he took with his camera, a very nice picture, so he put it on the marketplace and got an NFT for that. And then we spent time, so this is the marketplace, and I showed you some of these things. This is how you mint, and we spent time that how you can create your account and create and your profile, and so all of this. And then again spend more time on Merkle tree, remember, because Merkle trees are also part of IPFS. So we said, because IPFS also stores, once it split something down into, these are the transactions. Ethereum also uses Merkle tree. And then I gave you a design problem as well for you to basically generate a Merkle tree and submit your assignment, and which was about multiple courses, and then just generating a Merkle tree of the courses, and then. So then lecture 11 was for IPFS. We spend more time that how the content-based addressing work, how a file is broken into 256 kilobyte objects. And then there is an object which points to all the where the other objects are, and then they put this into a Merkle tree. And so we went through this, and there is this the table which has the content, where different contents of the file are. So we spent, and then I said, now people are almost coming up with equivalent applications. There are browsers, there's video conferencing application, Facebook, messaging. So they are coming with another type of application where you don't kind of store thing at a central server, okay? So just are distributed, so people are coming up with newer applications. I showed you this storage, which breaks your data, so you can actually buy some storage here, and it just encrypts and spread it to different clouds, spread all over the world. And once you want to get it, you get it. And then we started discussing something interesting, which is the finance. And we said, what is finance and DeFi application? And in the DeFi, I told you that how you gauge whether business is doing good or not, and spend time about the balance sheets. Okay, so if I ask question just about just finding out some of the terms here, EBITDA, EBIT. So I hope that you should be able to do that. Okay, so the simple concept I showed you 2 or 3 income statements, that how these are computed. And then we talked about financial instruments, that how the people invest, okay, your money into businesses. And we said these are the 3 instruments, whether they buy stocks with your money, and you can by yourself go buy stocks, or you buy bonds, and mortgages, and then there were derivatives. And we said derivative has the maximum, this is $1 quadrillion capitalization is on this. And in derivatives, we said there is hedging and speculation. Hedging is where you reduce your risk, and speculation is where it's a volatility of the market. The market is changing, and you try to guess and try to earn your profit by mere speculation. And we said it's a zero-sum game. So I may just ask you some questions which just checks your basic understanding of these concepts, basic understanding of the concepts, like about these instruments. Remember about these are the financial institutions which basically invest as an institution. They may be banks, they may be mutual funds, and I told you about the hedge funds. And hedge funds are where these are for the rich people. So there is no regulation on them. They can just, and they are the mover and shaker of the market usually. Okay? Mutual funds, they are decent because they have a portfolio, they take public money, they are answerable to the government as well because they are taking people money. So mutual funds are different. They though invest in stocks and bonds, but hedge funds are there. Usually they are not regulated, and they cannot market themselves. They cannot get public money. Basically, people having more than $10 million can only invest in a hedge fund. And then we talked about arbitrage, where you gain the difference of the two markets. If something is selling costly here, cheaper here, you buy from here and sell there. And usually it is done electronically, that if there is a little difference, electronic transaction, like you buy something from this exchange, sell it to the other exchange. So we talked about decentralized and centralized finance. And DeFi, I said, if you really have to invest, whether you explore the DeFi platforms instead of just investing in your cryptocurrency. And the DeFi means that you can lend your money to this platform. Okay, so if you are lending your money, it is fine, you will get your money back. But because you are lending it to a smart contract, and you yourself may be a borrower, so once you borrow the same money, you have to deposit a collateral, and then you can just play with whatever you have, so within a margin, and then once you return that, okay, after you gain some profit or don't gain some profit, and then money is sent back to the lender, which you yourself are the lender. So we talked about multiple platforms, and people are heavily, and also this is about the hedge funds are also investing heavily. And there was a study which says that Bitcoin goes up because of the hedge funds going up, because more and more people taking more risk, okay, and then there are like people who are retailers who are just playing with little money, so they basically get crashed into once the big players are just moving the cryptocurrency up and down. So lecture 13 was, this was where I can answer some of your questions. Okay, how the consensus happens, and definitely there will be a question from here, how the consensus happens in a permissioned blockchain. How the consensus happens, okay? So there is an endorser, okay? There are nodes, there are two types of nodes, okay? Two types of peers. One type of peers are called endorsers.
And these are defined at the time of creation.
At the time of creation, the framework allows you to basically create the system. Admin would say, this person who has this IP address is basically an endorser, and this person with this address is just a committer. Okay.
The concept is just like that when we create a network, we give
Yes.
some rights to
जिस तरह आप देख लें, जिस तरह let's say the way you create in WhatsApp. Okay, WhatsApp you make a group, then in group you start adding people. ठीक है, because you are the administrator, you say I add this, I add him, I add, and then to some you give privileges as an administrator also. You say these four are administrator. Some you say you cannot even write comment. Okay, you say you cannot, so you can just say nobody can write comments, only I can write comments. Nobody can make any post, only I can make posts. You know, so you can just configure what the different people in the network can do by yourself, by just configuring it. So they provide a very nice configuration environment where you can configure every actor to have this power or that power. So, but to make it simple, they have said, okay, these are the different types which you can have. Okay, here is so an application, as for example, case registering a course in FAST. You have an application. So this is an application. It's a client application. Okay, and as you were asking about the endorsers. Okay, so you submit a request, which is a transaction, registering a course. Okay, this is your request going to an endorser. Okay, so this is number one. You submit to an endorsing peer. There may be multiple endorsing peer. For example, there may be of accounts office, registrar office, dean office. Okay, the three, depending upon the logic which you have created, there may be three people. There are three peers. Those are the endorsing peers. You send them the request. Okay, so this is, they execute your request. Execution means they have a read and a write set. They said, this is the student, okay, this is the course, just reading, wants to register in this course. So they execute, they say, this guy will take this course. So they write the name of the course. So the write set is that, so this is a key value pair. Okay, it's a key value pair. So what they do is, the key value pair, a transaction is, let me.
So when this endorser is writing something,
Ji.
he is changing key pair value.
Yes, a transaction means that you are changing a key pair value. Okay, so basically there is a key pair value. Which key pair value you are changing is a read, write, set. Okay, a read, write, set. That this is the value in my state table where you are a student with all the values, maybe which semester, how many courses you have taken, and this and this. So these are the read set. I take out the read set. I say this course you are taking. Okay, that is the write set. So this is what happens in endorsers. Now what the endorsers does is that they execute the transaction and they say whether it is a valid transaction or not. Okay, they say there is an endorsing policy running in the application. Like if the dean says yes, if the account office says yes, if the registrar says yes, only then you can have this transaction. So this logic runs here in the client application. Because I have coded the client application which you have loaded from this is the application running on your mobile. I said, okay, this is, I endorse, and say if all three endorses, or this is the consensus which you have to build in. You say only one endorses is fine. In some scenarios, you may say if only one says yes, it is okay. In some you may say out of 3, 2 says yes, it is okay. So it is and or relationship. Or in some cases you say no, if everybody says yes, only then you endorse it. Okay. So if it is endorsed, then the transaction is sent to the ordering peer. Okay. It goes to the ordering peer. Ordering peer is just putting the transaction. Let's say if only FAST only allows 5 students from case to register in a course. Okay, so he is just collecting, and he gets 10 requests. Right? The orderer gets 10 requests that these 10 students want to register. So he'll put those into order. Right? He'll say request 1, 2, 3, 4, 5, and 6, 7, 8, 10. He'll put all the requests, and he's not saying I will drop these 5. Okay, he will put all the requests in order as they were received. Okay, he'll put order, and then he will send this to every node which is a committing node and the endorsing nodes. Every node gets a copy. Okay, every node gets a copy. Now they verify the transaction. They say, oh, these 5 transactions are okay, but these 5 transactions are not okay. They still record them. Okay, they still record them, say these are the 5 transactions which are okay, these are the 5 transactions which are not okay, and they basically create a block, put that in their ledger. Now everybody who is a peer or a committer has now this block created. Okay, and we say by this time of June last time to register in this course. Okay, so just collecting, and then it makes a block, and the blocks is created, and also there is a world state which shows that, which is the
Sir, what about if one student has made the request twice?
it will also take care of it. Yeah, this is a double spend problem. It's this verify. At this stage, it will get the double spend problem will be checked at the verification stage.
For example, there's
Yeah.
checking that one student is actually twice, so there are actually 900.
Yeah, because remember that you are just sending, and you have said you.
This guy will drop that double.
Everybody will drop that. That is the consensus, because every peer will drop it.
The committing peer.
Not only committing, but the endorsing as well. Everybody is going to drop that. Okay? Everybody is going to drop that, because same logic is running. The same smart contract is running everywhere. Okay? So everybody is going to drop that. But the committer pairs are not going to execute your transaction. Okay? For example, there may be just a student affairs section. Okay, they only need to know that, okay, the dean and registrar and these people have endorsed, it is fine. I only need to keep a record. Okay?
So can we go back?
Ji.
At what time ledger would be updated?
It's up to you. It's up to you that you decide कि ledger आप कहते हैं I want, because I say this is the last time where people can register. Okay, and you say so a block should be created after this, or you may say after end of every day you just create, update the state, and you say end of every day I'm going to just update this. So it is up to you, the programmer, that when do you want to create a block into your ledger. Right? So this is how the same thing is shown here, that you basically, this is your client application. So this is your client application. Okay, and then a client basically invokes, which is called a chain code, a smart contract. Okay, it invokes to all the peers. These are the peers, peer endorsing peer 1, endorsing peer 2, endorsing peer 3. So there are 3 endorsing peer. Okay, so it invokes a contract, all 3 of them execute. Okay, but they may have different role in the organization, so they may or may not endorse. Okay, so after this, they basically, this is the endorsement, endorsement. They all either say yes or they say no. Yes or no. Comes back to the client application. अब the client application sends, if the endorsement policy says yes, enough endorsements have been received, you send it to, and this is definitely, I'm going to give a question on this. Okay, so you just make sure that you understand, you should be able to.
If the endorsements are received, only then it will be delivered.
As per the endorsement policy, enough endorsements are received, then you send it to the ordering service.
Otherwise, no.
Otherwise no. You say registrar ने कह दिया आप नहीं register करा दोगे, खत्म बात. Okay, finished. You don't. So only you say okay, yes, goes to the ordering service. Ordering service, what it does is it just put them in order. It is not deciding whether to verify or not verify. Just to make sure, because this is a central, this is the node which is central to this permission blockchain. They don't want to load it with a lot of work. Okay, that is the logic. They say don't put it to verify. Okay, though it may be good that they just this verify, but say no, because there may be thousands of transactions coming. Say just put it in order and then broadcast it to committing peers and all the endorsing peers as well. Ye sab ko jayega, and then it will be verified and placed in the ledger. Okay, so this is how the things would work. देखिए अब वो आपकी बिजनेस लॉजिक है, जैसा मैंने कहा बिजनेस लॉजिक में अकाउंट्स वाला चेक करेगा हैव यू पेड द फी और नॉट. ओके, गोस टू द बैंक अकाउंट से ओ ही हैज नॉट पेड द फी, यू से आई एम नॉट endorsing it. Okay, and then endorsement policy may say that if he is not endorsing, end of the story, you don't even look at the other endorsement, so you just drop. and you must generate an event that you have not paid the fee, so you cannot take this course. जी sir. नहीं, ordering pair is not a client application. ठीक है, it is inside your network. ठीक है, it is inside your blockchain network. It's as जैसे हम देख रहे हैं, it is inside your blockchain network, and so the ordering service, क्योंकि client जो है ना वो तो एक student है, so you don't want to run your ordering service onto a student's mobile or on his laptop computer ना. So this is how it works, and then I showed you like there are multiple peers and like very elegant framework. Honestly, it's such an elegant framework that a peer may have multiple ledgers, multiple contracts. Okay, so all, yeah. Okay, then you will put it in the in your chain code, in your smart contract. You say if it is CR, okay, he must be given the priority. So there is some reserves. There is some reserve slot for the CR. So it will become part of your smart contract.
It can be, but we have to modify.
Yeah. You can just, because that is the core business logic, you can make any business logic. But it is about almost this framework handles almost every use case so elegantly. So this is important. Like only few peers which are endorsing peers, few peers which are committer, there is an ordering service, there is a client application. That's the end of the story. So everything is basically partitioned onto these, and they are just actually executing what are just piece of code. Rest everything is taken care of by the framework, and writing a piece of code is very simple. It's just your business.
Will we be having such strong question to create some design?
Yes, 100%.
We can create design and we can present logic.
Yes, you can present logic. For example, you can say, "Acha, I'll give you few sample questions to work among yourself. So I would like you to come up with the endorsement logic as well. If this is the scenario, what should be the endorsement logic? For example, I say design a voting machine. Okay, so now a voting machine where I say there are, let's say a person goes to a booth to vote, and there are 5 people from different parties or 10 people from different parties. Your identity is presented to all the representative of different parties who are sitting there to verify. Okay? Now the endorsement may be that if everybody says yes, he is a valid voter, then, or it may be like out of 10, 4 says yes or 5 says yes, he is a valid voter, you should allow him to vote. Okay? So what happens is you go to the polling booth, you have this application which you have downloaded from Election Commission of Pakistan, and you come, you enter, and once you enter, you say, I want my ballot, I want to cast my vote. So you say, I want to cast my vote. So then these are the peers who are sitting in the election booth, and there are like 5 or 10 of them, and there may be a resident officer as well who has the final say, for example. Okay, and then they may be just committer. Okay, they say they are committer, they only check whether he has already casted his vote or not. Okay, rest of the nodes and the peers, you say you don't want to give this power to these people, or the parties may say no, we want this power. Unless we say he is a valid voter, the system must not give him an e-ballot. Okay, so he comes in, he makes a request. 10 people of different parties who are sitting there with the terminals, they get it and they check and they basically endorse, or they don't endorse. Okay, goes back to the application, and you have now their endorsement policy. Your endorsement policy is okay, yes. So once it says yes, then it goes to the orderer. Okay, it goes to the orderer, and orders what he sees, okay, this guy, if like puts them in order. Let's say you say every 5 minutes or 2 minutes he should just collect all of these and send, let's say, the 10 people who are on different polling booths, and 10 people have entered, and you are processing in batches of 10, or processing in batches of 10. Okay, so comes and then you basically send it to everybody. Yes, this is the guy. Okay, and you go in the state table and you have a read-write set. What is the read-write set? This is the national ID card number. This is his name. This is his father name. This is his address. Whether he has already casted a vote or not. And he has already casted a vote. Okay, or you say right values, he is casting a vote. So you put a tick there that this is the right. So the read set is just his information, and the write set is now he is casting his vote. Okay, so he is casting his vote. He has not casted, he is casting his vote. Okay, so once it happens, then you say, okay, as a matter of fact, yes. So the verifier would see, okay, it's a valid vote. So verifier is going to check the double spend problem. A double spend problem is if the read-write set, if there is a read-write set in the state table in your ledger, okay, which says this guy has already casted his vote, so you nullify his, and you make that transaction in the ledger that this person has tried casting his vote twice, but you don't make it into the sum which you are calculating that which party has how many votes. Yes, इसका डिजाइन बना ले, इसका डिजाइन इलेक्शन
कॉन्सेप्ट होता है इलेक्शंस का,
Yes.
होता है कि एंडोर्सर्स जो हैं वो पार्टी के लोग नहीं होते, एंडोर्सर्स जो हैं वो प्रेसिडिंग ऑफिसर या असिस्टेंट प्रेसिडिंग ऑफिसर।
लेकिन देखिए बैठे होते हैं सारे, वंस यू गो वो सारे लाइन में बैठे होते हैं, ठीक है, दे आर द पोलिंग एजेंट,
वो अंदर नहीं होते,
नहीं दे सिट इनसाइड।
मैंने खुद प्रेसिडिंग ऑफिसर की
देखिए
होता है, उसमें ये है कि हमें लिस्ट मिलती है फ्रॉम द मजिस्ट्रेट, और जो लिस्ट हैं वो हमारे पास ऑथेंटिक होती हैं, वोट लाते हैं, हम उनको चेक करते हैं, और जो एजेंट्स हैं वो हेल्प कर सकते हैं या वो बैठे होते हैं, और हम उनको देखते हैं और हम उनको वोट इशू करते हैं। और हम
अच्छा, जो मैंने जितने वोट डाले हैं ना, माई एक्सपीरियंस इज दैट एवरीबडी हैज अ लिस्ट एंड दे आर टिकिंग दैट।
हमने देखा होता है, हम चेक करते हैं
जी।
क्या ये नाम इसमें आ रहा है, फिर हम
हाँ देखिए, जिस तरह से अभी आप कह रहे हैं, लेट से
एग्री और डिसएग्री के जी है या
या यू कैन, देखिए दो चीजें हो सकती हैं, यू से दिस इज वेरी इंटरेस्टिंग,
उसमें हम करते हैं।
yeah, this is very interesting, like definitely there will be a question on this. Okay, that's what I intend to give you a question on this. Okay, 3 घंटे का है अभी तो 5 हुए हैं। Okay, so this is because this is very interesting design.
इस तरह के सवालात आप बता रहे हैं ना, ये तो 6 घंटे का पेपर होगा।
कोई बात नहीं, मैं 6 घंटे दे दूंगा यार, परेशान क्यों होते हो?
सर ये
Okay.
कंप्यूटर और वेरीफायर बेसिकली क्या
सर इस टाइप की डिजाइन प्रॉब्लम के लिए तो काफी टाइम चाहिए।
जी जी, देखिए मैं तो आपको बता रहा हूँ ना डिजाइन प्रॉब्लम क्या होगी। सो यू कैन जस्ट डिस्कस, प्रिपेयर योरसेल्फ मेंटली दैट, देखिए अब
सर मुझे आपकी बात से समझ आ गई है, हम डिजाइन बना सकते हैं, डिजाइन को सपोर्ट करते हैं।
तब अगर एग्जाम बनाना है, एग्जाम देना है, तो मतलब ऐसा ही हम एक इसकी देखते हैं कितना होता है।
देखें, पहली बात यह है कि डोंट वरी अबाउट के लेंथ ऑफ द पेपर। 3 घंटे में जितना हो जाएगा, हो सकता है 3 दिनों का पेपर हो, वट एवर यू कैन डू इन 3 days और 3 hours, दैट इज योर पेपर। ओके, सो इट इज काइंड ऑफ अ,
आपसे कोड की तो रिक्वेस्ट करना चाहते हैं, अगर हम एक मिनट ध्यान दे दिए और आप
बताइएगा दोबारा, ठहर मैं अपना माइक बंद कर लूँ ना, प्लीज से इट अगेन।
एक मिनट की बात की थी आपसे, प्रॉब्लम हो गया मैं वैसे भी ऑनलाइन ही एंटर करेंगे आप कह रहे हैं।
यार बच्चा पहले चुप कराओ, वो जरूरी है।
नहीं बुरी बात है यार, कोई बात नहीं, आप भी कभी ऐसे बच्चे होंगे। तो मुझे शायद आप ये कह रही हो कि पिछले एग्जाम में प्रॉब्लम्स थी कोई, टेक होम लेना
सर मैं
है।
कहना चाह रही हूँ कि अगर आप टेक होम ले लें, क्योंकि बहुत दूर दराज से हम बीएस स्टूडेंट से
जी मुझे पता, समझ आ गई बात। मैं अच्छा, वो कह रहे हैं टेक होम ले लें,
अगर ऑनलाइन हो जाए,
ऑनलाइन हो जाए, चले ये let me think about it and then I'll get back. असल में होता ये है कि वो जो बेचारा चेक कर रहा है ना, उसके लिए बड़ा मुझे, otherwise I have no problem, एक one is that I have to make a paper which is different for everybody. So वो एक challenge होता है. Then मुझे उसका भी मसला नहीं है. The problem is the person who is checking. वो बेचारा वो उसको निकालेगा, कोई कहे मैंने भेज दिया है, मैंने नहीं भेजा है, मैंने इधर भेज दिया है, वो कहेगा मैंने इधर भेजा है, कहेगा मैं तो भूल ही गया था, मैंने भेजा ही नहीं है. So no, so just there's so many use. चल देखिए मैं ये चले मैं ये कह सकता हूँ, मैं ये कर सकता हूँ कि हम ये करेंगे, जो लोग यहाँ पे आगे देना चाहते हैं, दे कम हियर एंड दे appear. Most of the people I would like you to come and appear in your exam from the campus. At least people who are in Pindi, Islamabad should come here, sit in the lab, relax होके बैठे, कोई मसला नहीं है, ठीक है. आपने सिर्फ नकल ना मारें, अगर आपने किसी से पूछना है तो that is also fine, but don't copy it because उससे फायदा नहीं होगा वैसे भी. there will be a little difference in every question.
सर मिडटर्म एग्जाम में एक और इशू हुआ था कि आधा हमारा पेपर चेक हो गया था, आधा जो है वो चेक ही नहीं हुआ था. फिर हमने टीए से कंसल्ट किया, उन्होंने बताया कि ये हिस्सा एक बंदा चेक कर रहा था, तो ये दूसरा चेक कर रहा था. तो
जी वो
काफी सारे इशू हुआ.
चलें, वो अगर किसी का स्पेसिफिक
एक ही अगर उसमें आप बना दें,
एक ही उसमें बना,
कंप्लीट हो जाए.
ठीक है, सही.
और सर मिड टर्म से पहले जो असाइनमेंट की सबमिशन है ना सर, काइंडली उसकी भी डिटेल
आगे कर दी हमने. एक तो हमने असाइनमेंट एक हफ्ता आगे कर दिया.
सर जो सबमिट हो गए हैं.
जी जी जी.
उनके पहले दो जो है असाइनमेंट वो ग्रुप में सबमिट हुए, उसके बाद इंडिविजुअल हुए, तो उसकी सबमिशन काइंडली वो
कंफर्म कर देते हैं. ही हैज चेक्ड, ही टोल्ड मी जस्ट दैट ये पता नहीं, ही इज नॉट सिटिंग हियर, बट ही सेड ही हैज चेक्ड ऑल द असाइनमेंट्स एक्सेप्ट द लास्ट टू. ठीक है, लास्ट के लिए तो अभी हमारे पास एक हफ्ता और है, एंड वी विल जस्ट टेल यू अबाउट दैट हाउ मच मार्क्स हैव यू गॉटन. और हम हर एक को वैसी ही लिस्ट दे सकते हैं कि किसके नाम के. जी जी बताइए. सेवन ही बहुत सारे लोगों ने किया है, वो आपको नहीं छोड़ेंगे, मुझे भी नहीं छोड़ेंगे. हाँ जी जी जी. अच्छा अभी मैं क्वेश्चन जी बताएं, पूछ लें, लेकिन मैं आई वांट के मैं
असाइनमेंट 6 में एक क्वेश्चन था सर, म्यूटेबिलिटी चेक करने के लिए जो कह रहे हैं ना, जब भी तो पैसे अगर आप चेक कर दें.
ऐसा म्यूटेबिलिटी तो कोई चेक नहीं करनी थी आप. नहीं ऐसा तो कोई क्वेश्चन नहीं था. HEC वाला क्वेश्चन था, वो तो बहुत डिफरेंट किस्म का वो था. Yeah, that is actually designing. मैं अभी let me just complete this. जी 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 जी. अच्छा चले मैं उसको देख लेता हूँ. मैं let me just complete एक मैं जो चीज़ आज बहुत ज़रूरी करना चाह रहा था वो मैं जल्दी से कर लेता हूँ, फिर then we will have time to take your questions. मुझे अगर आप there is something which I believe is bigger than the Bitcoin. And I want to highlight that. Okay? नहीं, not NFTs. क्या हो सकता है वैसे? नहीं नहीं नहीं. Grid chain blockchain. This is, this definitely is going to be bigger than anything. ठीक है? And I would like somebody to have a startup in this. ठीक है, दुनिया में बड़े startups बन रहे हैं इसके ऊपर. And I'll explain what it is. Okay, like very interesting areas. ठीक है, I'll just explain. This is about because electricity is actually value that goes from one point to another. It's not, Bitcoin is not a value. Everybody is confused. NFTs are not a value. But kilowatt hour is actually something which you are using. Okay, so it has value. Like if you bring blockchain in this, then it really becomes valuable, very valuable. Okay, so this is where the future of electric grid is moving for sure, and people believe that it is going to be bigger than the Bitcoin. Okay, I've read several reports say it is going to be bigger than the Bitcoin. So let's just quickly cover this, and we know what an electric grid is. Electric grid is where electricity is generated at generation points like Tarbela and Mangla, and there may be a nuclear power plant, and and then it is basically using transmission network, transmission lines. So you step it up and to reduce the losses. It's a lot of electrical engineering, but let's not worry about the electrical engineering part of it. And it gets through a distribution network. So there is a transmission network and a distribution network, and it gets to the customer. Okay, so an electric grid has 4 components. One is generating plants, the other one is transmission lines, then there are substations, and then the substations basically then distributed through distribution lines to the end customer. And today how electricity is produced, so there are different ways like nuclear power plant, hydroelectric power plant, coal-fired power plant, diesel-fired, geothermal, which is uses steam, and gas-fired using natural gas, and solar power plant, wind power plant, tidal power plant. So all these are different types of power plant, and even today about 80% of electricity is generated using non-renewable resources, hardly polluting the environment, because they burn the fossil fuel. Everybody is realizing. So for example, this is in India, where it is a coal generation in India, and India is the 3rd largest emitting country in the world, though they are also very aggressively working to reduce this percentage. And here is the largest nuclear power plant in Canada, and because accidents happen, we know this is something which happened in 2011 in Japan, and in 10 years there is devastation. And slides move nahi ho rahi. Sorry, I need to go back, and वो slide कोई और share हुई भी आप. Let me just share it. जी ठीक है, आप नजर आ रहे हैं जी. So this is about the electrical grid. So this is about the electrical grid, and I said electrical grid is basically taking the electricity from where it is generated to the end consumer. It is mostly works in one direction at this point. That electricity these are the 4 different components of an electricity grid, which is generating plants, transmission lines, substations, and distribution lines. And these are the different types of power plants that basically generates electricity, and 80% of electricity pollutes our environment, okay? And because they burn the fossil fuels, and the people are not very happy about this, the governments are not happy, and general people, they have this awareness and they want to use green energy. So there is a drive in many countries that they want a certificate that yes, they are using energy which is produced through green means. So they get actually a certificate as well, okay? So because of all these reasons, accidents and this, so there is a move towards more green energies, and the countries are continuously. So there is an index that how much, for example, in Pakistan we say about, if we include the hydropower, about 65%, we will get to 65% maybe. But I think 30-35% of our electricity comes from hydroelectric power plants. So, so this is how this whole thing happens. These are the transmission lines, and then the substations, and so the substation sits between where the electricity gets generated through the transmission line, gets to a substation. And if you think about this, all these are the transactions that are happening. The electricity, how much is being produced, getting to the substations, and from the substations being fed to different parts of the area which the substation is catering. And at the substation there are circuit breakers, and they also step down the voltage, and because It was earlier step up to reduce the line losses. But again, you have to invest humongous amount of money in the infrastructure. And you cannot just take that infrastructure to everywhere. In Pakistan, about 30% people have no electricity, like only 70%. For many years, we are only stuck at World Bank report is that only 70% of population in Pakistan have electricity. And because it requires humongous amount of investment, laying out all the transmission lines and the substations and distributions. So this is, you must have seen the substations, right? आमतौर पे वो उधर बार वायर लगी होती है, and this is where the transformers, you see many transformers feeding going into different parts of that area. And so this distribution going this. So traditional grid is where different sources, if there are different sources, they are fed differently into different areas. And now that the trend is that you have all the sources and a distribution like an internet, right? It's like an internet that you can just have all the sources, and then you can basically send any source to anybody, and you can also keep a record. Like the world is moving towards smart grid. Okay, the smart grid have this capability. It is a two-way communication. Okay, so two-way communication means that there is a flow of information going from a household, that how much, with the smart meters, that how much electricity every household is actually currently basically consuming, and this information going up. And so you can basically have a two-way communication, and then you can very nicely control. Now they actually plan based on the previous historical values, that how much electricity will be used where, and they cut down electricity if the production and demands are different. So they cut down electricity. There are load shedding schedules, they say, and they cut down electricity to industries, or so they just make a plan based on what they have learned through the experience. And so this is called a national grid. Electricity being generated, and there are step-up transformer which bring it up to kV, and then these are the transmission lines, and going down to 25 kilovolt, and then what we get in our home is about 40 volt AC supplying to the households. And this shows a UK electric power transmission, or called electric grid, and this is Pakistan. Right? So this is Pakistan power grid, and you see Tarbela and Mangla and Ghorki and different places from the electricity gets generated, and through these transmission lines they gets to the different households. First application of blockchain is right in our existing system. This is the existing. What government of Pakistan did, that there used to be just WAPDA handling all the three aspects of electricity generation, transmission, distribution. So you pay bills to WAPDA. And then they decided to split it up into three different organizations. WAPDA is basically doing the WAPDA, hydros, and some IPPs, which are thermal. And then there are thermal, using thermal means of GenCos, which is generation companies. Then there are nuclear power plants, and then there is this NTDC. Okay, so they created an organization named National Transmission and Dispatch Company. So this is central to dispatching this electricity. So you see that all this electricity kind of logically coming to this central dispatcher, and this central dispatchers, then they have many discos. The discos are, like we have Islamabad is a disco. So discos are the distribution company. So they made many distribution companies, and they are handling the distribution, that how they basically distribute to bulk power consumers and to other consumers and the large consumers. And then the flow of money, this shows financial flow. So these are the finance. So there are electricity transactions, that how much electricity gets produced here, how much comes here, amount of electricity going to different discos, and they have different load shedding, because if they have only fixed amount of money, the demand is more. So they decide that which disco should be fed how much electricity, and you must be knowing there are places where they have 8 hours of load shedding, then there are places where there are 2 hours of load shedding, there are places where there is no load shedding at all. So primarily based on some criteria, they decide that how they are going to balance the, but it is kind of manually done at this point. It's manually done, that this is how they are doing the planning, and so there is no smart
Sir, just to add one thing, sir, ये भी decide करते कि डिस्कोस के साथ आप डायरेक्ट ऑर्डर भी देते हैं थर्मल पावर का, अगर वो उनके पास अवेलेबल हो तो वो डेट पे लोड सेट करते हैं, डायरेक्ट ऑर्डर होता है सर एनटीटीसी के पास, एलबीसीसी के पास।
सॉरी दोबारा बोलिएगा आप।
डिस्कोस से डिमांड लेते हैं और जनरेशन की तरफ जाते हैं तो फिर डायरेक्ट ऑर्डर देखते हैं कि कौन सस्ती बिजली दे रहा है।
बिल्कुल बिल्कुल ठीक है। सो तो कह रही थी डिस्को से, आई थिंक ये नेपरा से हैं कोई, है ना? सो आई थिंक दिस गाय इज फ्रॉम नेपरा। मैंने माइक तो नहीं बंद कर दिया। या आई थिंक दिस गाय इज फ्रॉम नेपरा। सो अच्छा हाँ बिल्कुल सही कह रहे हैं। सो कह रहे हैं इनसे डिमांड लेते हैं। सो दे टेक डिमांड्स एंड देन दे चेक, बिकॉज दे टेक डिमांड एंड सी which electricity is cheaper, and because perhaps this electricity is cheaper, this is expensive, right? So if you are using, you don't want to use this, for example, you don't want to use IPPs, thermal, maybe you want to use. So once they have different tariffs, why they are different tariffs? Because there is more demand, and once there is more demand, they have to produce electricity through expensive means, and once the electricity being produced is expensive, then you basically you sell it to the user, the expensive electricity, because now you have to turn on kind of the plants which are producing electricity at an expensive rate. So KESC is different. It is kind of an independent, where it has the IPPs as well, and they have the nuclear power plant as well, and so they are kind of a bit different. They are also doing the distribution, and they are handling the transmissions, and they are definitely getting the electricity from national grid as well, and they could. And then there is, if they get it from here, then they have to pay the Central Power Purchasing Agency. You see in this a beautiful use case of blockchain, even here. Right? Why? Because we were one involved in CARE to actually interconnect their power monitoring meters at different places on this electric grid, so that at one monitoring, this is actually happening on papers, okay? There is no central place which automatically is getting data from different meters. At least it was not there a few years back, okay? अब क्या होता है कि वो बता रहे होते हैं कि इतनी गई इधर, इतनी गई इधर, इतनी गई इधर. They may be just reading from the meters, but the meters, though they have the capability to be connected on the internet, so that you have one central power management and monitoring center where you could see that how much electricity is actually coming and going to different places. So we actually did this work that we connected, like in Mangla there were 8 meters, in Sangjani there were 3, and Burhan there were 6, and we connected them and we brought all the data at a central location which was in Wabda House, okay? But you know, this is also a big source of corruption as well, because आपको पता है बहुत ज़्यादा बिजली चोरी होती है. It's just in the air. Okay, he'll say I have basically sent this much, and I may or may not be correct in this, but for sure पाकिस्तान में बहुत सारी बिजली चोरी होती है, ठीक है? और अगर if you balance it out, क्या इतनी जनरेट हुई थी, इतनी बिल हुई है, बाकी किधर गई है? Okay? If you have a system like this, then you can just जी जी
अगर हम ये देखना चाहते हैं कि बिजली चोरी तो हमें कंज्यूमर साइड पे जो मीटर है ना उसको
नहीं देखें, कंज्यूमर साइड पे मीटर पे नहीं बिजली चोरी होती, बिकॉज if you have played with them, tampered with the meter, yes, but otherwise now they are putting smart meters. Smart meters mean that they also communicate. Otherwise a meter reader would come, you know, he'll just do the reading, and there's no way, because he cannot synchronize everything. How can they figure out how much electricity has been stolen? Because you are taking meter readings, okay, at different times, unless like it happens the same time, only then you know कि इतनी produce हुई थी, इतनी consume हुई है ना. अभी तो बेचारे आते हैं सिर्फ billing देख रहे होते हैं. All they can do is they check, अच्छा इसका इतना मीटर था, अब इतना था, they take the difference, find out that this is how much your bill should be. And but otherwise, like if you automate this, you put blockchain, you put smart contract, the transaction, every meter is basically sending, and it is as a transaction. So you can do this. So there are many issues with this traditional grid. But what is more exciting, and it used to be only 1.3 billion people without electricity. Unfortunately, now so there is a drive for renewable energy. ठीक है, ये सारा पैराडाइम चेंज कर रहा है. दिस इज व्हाट इज ब्रिंगिंग ब्लॉकचेन टेक्नोलॉजी इनटू सेंटर ऑफ इलेक्ट्रिसिटी डिस्ट्रीब्यूशन. दिस इज व्हाट इज मेकिंग ब्लॉकचेन टेक्नोलॉजी वेरी मीनिंगफुल. एंड आई विल टेल यू व्हाई. सो आपको खुद ही अभी नजर आना शुरू हो जाएगा. ओके, सो बिकॉज नाउ इलेक्ट्रिसिटी इज बीइंग प्रोड्यूस्ड एवरीवेयर. लाइक यू पुट योर solar panels on the roof of your house, and you become an electricity generator. You're producing electricity, means you can sell it to the grid.
Going back to the grid.
Yeah, so you can sell it back to the grid. ठीक है ना? Precisely. अब now once you are selling it back to the grid, ठीक है, अब आप ग्रिड पे आपको नहीं पता, वो कहते हैं मीटर आपका रिवर्स कर रहे हैं, but not with that same rate. And
Very smart LEDs there. This is my personal experience at my home. We have deployed a
जी, जी.
big solar panel and very smart LEDs there. And every moment of time we can see
या बिल्कुल ऐसे ही है. देखिए अभी क्या हो रहा है कि all these people who are generating their own electricity they are presumer. They are producer and consumer themselves. Okay, so you are presumer because you are producing and you are consuming electricity. But then there are people who are actually investing. They say, okay, I'll put this. I have this piece of land and I can just put this solar power plant, and I'm producing this much electricity. They have to go and take permission from, let's say, NEPRA, who is the regulatory authority. Even you have to take permission from NEPRA that I want a solar system, I want it to be grid tied. If it is not grid tied, you don't need to. But if it is grid tied, that you're feeding electricity back to the grid, you have to take permission. Okay? So, अब क्या हो रहा है? Okay, because of this, now there is about 87% of the population of the world which has electricity, access to electricity. And Pakistan's situation is still bad, that we have only 73.91% people who have electricity. So a very large population does not have electricity. So the smart grid is becoming very, very interesting. And the blockchain technology in smart grid, where basically, what is a smart grid? A smart grid is an intelligent grid. Okay? So it is intelligent because now there is two-way communication. Okay? A two-way communication. Now the devices in your house are also smart. Your refrigerator, your dishwasher, your EV which charges your car. Every device in your household is a smart device. Okay? And it continuously communicating. When there is a load on the grid, it'll talk to your smart devices. The dishwasher will say, don't wash your dishes. Don't charge your car because, and automatically a smart contract kind of is saying, don't do this because this electricity is expensive and you only do what is very, very essential. Okay? So the smart grid is becoming, it is distributed, okay? And then it is, electricity is being generated everywhere. So there's like many pockets where the electricity is being generated and is being consumed. Okay? And so what people are trying to do is that let's sell this electricity peer-to-peer. If you are generating electricity, instead of feeding it back to the grid, you sell it to your neighbor. You say, this is the cheapest because the electricity does not have to come through the transmission lines to the distribution network. It is like you say, oh, I have excessive electricity. He says, oh, I want this excessive electricity. So a blockchain network in a neighborhood, it basically you are trading your electricity through a smart contract to your neighbors, and then there is a coin, and which is you can peg it against a rupee. So you say, okay, you got to charge your meter, for example, if it is running the smart contract with some money. So you go You deposit some money in the bank and they give you a code, for example, and you feed it, and this is like 5,000 rupees, 10,000 rupees, and that now gets traded. It is a token which is usually pegged against a fiat currency. तो अब ये जो एक ट्रेंड आ रहा है, this is just an amazing trend which is decentralized drive, where now electricity used to be like this or like this, it is becoming like this, distributed, and now it is, and the blockchain technology basically is just revolutionizing the way our electricity distribution network is going to work. It's just revolutionizing this.
If this operation is between central authority will be
Central, there will be no central authority. That's the point. There is no central authority. So yeah, everybody start producing some a little excessive, and you have this neighborhood, then it becomes a microgrid, and you start then feeding it to the next mohalla because there is an excessive. In your mohalla, then you can feed it to another mohalla, and then these mohallas can feed into another town. So it just becomes distributed. And there is a peer-to-peer that you are just paying to your neighbor, anybody who is producing, right then and there. Everybody is self-sufficient. Okay? So this is the trend, and there are so many startups that if money can move peer-to-peer without any central authority, why not kilowatt hour? Okay? So that is the concept, and you will find out. So the blockchain technology जो है have the potential to play a key role in this transition, offering decentralized interfaces and system, alternative approaches to the current organization from the energy market, and so इसके अंदर blockchain technology की बहुत बड़ी application आ रही है. It says more than Bitcoin, blockchain looks to be the technology that will deliver the smart electric grid. Okay.
इधर अगर ये क्लास खत्म हो जाए ना तो सवाल
अभी थोड़ी 2 बजे है अभी तो भाई.
सर ब्रेक भी कोई नहीं लिया.
हाँ आज नहीं ब्रेक होनी, आखिरी क्लास है, बस अभी खत्म कर रहे हैं, थोड़ा सा आखिरी रह गया, 10 मिनट और इंतजार कर लें.
सेम अमाउंट पे जो है आपको वापस रीपे नहीं कर रहे होते, क्योंकि कुछ अमाउंट जो है वो आप पे उसको मैच करने के लिए भी एक्सपेक्ट कर रहे हो, अमाउंट नहीं करते. तो एक बड़ा इशू आता है ग्रिड के अंदर, वो आपकी जो पीक है उसको सर्च को एवरेज आउट करना. ये अब रिन्यूएबल सोर्सेज का मसला ये है, ग्रिड के
वो इसमें सारा है. इसमें देखो, वंस यू हैव, ये दो काम करता है. पहले तो इसने स्टेबल करना है ग्रिड को. ओके, because it very intelligently stabilize the grid as well, because now they are smart devices. ठीक है, वो कहेगा इसको बंद करो, इसको बंद करो. It'll make sure that your grid is stable. So that the blockchain technology does, the distributed blockchain technology does two things. There are two types of transaction. One is the transaction which is sending information that कि मैं इस तरह से ये produce कर रहा हूँ, okay? And then there is that actual financial transaction. So there are two jobs which blockchain network should do in this case, and which the networks are designed to do. Blockchain networks, one is to stabilize the grid, and second is that do the transaction. ठीक है, वो जो आपकी चीज है वो इसका एक कोर. जी जी बताएं.
कंप्लीट नहीं किया इसमें, मैंने कुछ मेरा कर रहा हूं. आई एम फ्रॉम द जेनको 1 and 3.
अच्छा, माशाल्लाह, जेनको 1 से हैं जी. गुड यार, ये तो बड़ी अच्छी बात है. अगर आप इस
सर मैं बैठा थी हैदराबाद में, उसकी रिक्वेस्ट कर रहा था कि पेपर में आप हमें थोड़ा सा रिलीफ दें कि पेपर हम कर लें, क्योंकि मुझे आना पड़ेगा बाय टिकट पेपर देने के लिए. बाकी मैं इसमें से डिस्कस करता हूँ जो मेरा आइडिया है, और मुझे पता है कि पाकिस्तान में कैसे इम्प्लीमेंट हो सकता है. ये मिक्स्ड और हाइब्रिड ही हो सकता है कि आपका नेशनल ग्रिड पे काम कर रहा हो, उसके साथ आईओटीज लगी हो, हाइब्रिड हो कि जहां नहीं तो just like the solar system वो पेयर जैसे पेयर दोनों.
जी बिल्कुल आप सही कह रहे हैं. ये हाइब्रिड ही होगा फॉर सम टाइम टू कम. दिस इज गोइंग टू बी हाइब्रिड. ये इतनी जो बिलियंस ऑफ डॉलर्स की इन्वेस्टमेंट है, इट विल रिमेन देयर, इट विल बी हाइब्रिड, एंड बड़ी अच्छी बात है. सो वंस यू विल गिव योर प्रेजेंटेशन, हम ज़्यादा उस वक्त सीख लेंगे. और बट इट इज़ This is how, but I'll just show you what are the things. So ये जो आपकी बात थी, जो ब्लॉकचेन टेक्नोलॉजी जो है ये दोनों काम कर रही है, ठीक है, is stabilizing the grid and primarily also giving you proof of authority that you this percentage of the energy which you are using is coming from green sources, right? So हमें यहाँ पे फर्क नहीं पड़ता, लेकिन बाहर लोग they take pride in saying 90% of my electricity is coming from green sources. I have the certificate, so you get the certificate of authority as well. अच्छा, ये एक है, this is a not for Energy Web Foundation, which has an open source code as well for the blockchain implementation, and they have the coin as well, and you can take out their coin and put a rupee which is pegged against rupee. So there is a software. तो मसलन जो मैं कह रहा था, if somebody makes a startup on this, right, or even submit a proposal that you want to make a startup, and you already have a code on this. So this has a source code which is an open source version, uses less energy to record provenience and track ownership, source type, location, time, emission. ये वो चीज़ें हैं, देखो ये कर रहा है, source क्या है, type क्या है, location क्या है, time क्या है, emission क्या है, right? So it has all this information and it uses this information to ensure कि जो ग्रिड है उसको किस तरह से उसने स्टेबल करना है, उसका भी मैं आपको थोड़ा सा दिखा देता हूँ, ठीक है. So this is these are called transactive grid. A transactive grid is basically this mode of grid where you are doing the grid by itself is making sure that it is stable, okay. ये ग्रिड की बैलेंसिंग कर रहा होता है ये खुद से, ओके. और किस तरह से हो रही होती है वो ये है, देखिए ये है आपका, यू हैव, दिस इज योर डिमांड, दिस इज लोड एंड दिस इज योर मैक्सिमम कैपेसिटी, ओके, एंड दिस इज द प्राइस. तो आप क्या करते हैं कि एज load is increasing, you make electricity expensive, more expensive, more expensive, okay. So once you make it expensive, your smart devices start going down, shutting down. So जब आपका maximum load है, so your price is maximum, okay. So as shutting down होता है तो आपकी price जो है वो start getting down, 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 और ये price इस optimal point पे tries to make sure that the grid is operated here where your supply is equal to your demand. जैसे ही लोड कम होता है it says कि आप कॉस्ट उसकी कम कर देता है, ठीक है, so that people start using their devices. कोई डिश वॉशर है, कोई ईवी चार्ज होना है, ये होना है, so that it again pushes the grid to its optimal operation point that it should ideally should operate here. So by dynamically playing with the cost, it tries to basically make sure that you are just operating on this point. And so this is very interesting. So this is transactive energy, and this is how it works. कि ये automated price responsive device control, express customers flexibility, customer system aggregates and this. So और फिर ये blockchain की बहुत सारी इसमें companies हैं. $1 billion का venture capital has gone into this. This is a company in Spain. So they have a platform developed by Barcelona startup FlexiDAO to obtain a guarantee of origin for renewable energy purchased by a Spanish bank. The guarantee certificate, the power came from 2 hydroelectric plants and a wind from the real. This is in Norway. It's a private blockchain, so you can have a public blockchain or a private blockchain. See? Record energy transaction in which commercial or residential customers can sell power from their solar panels or batteries. This is Brooklyn. There is a microgrid project in its 3rd year of operation as the first successful peer-to-peer blockchain system operating through smart meters. So this is where 500 people are buying and selling locally in Brooklyn. And then there is Switzerland. There is another local straight solar energy using blockchain. So this is, again, there are many other countries. I've seen in Germany there are many startups. In Estonia there are many startups. Okay, so they are trying कि जी इस तरह से blockchain के ज़रिए peer to peer, once you are transferring kilowatt hour, आपके tokens जो है वो transfer हों, and you buy and sell, and then you make sure that the grid is also stable. So this is all I wanted to cover. So अब आप कोई क्वेश्चन है तो आप पूछ सकते हैं. Any questions?
सर जबरदस्त.
हाँ जी, वालेकुम अस्सलाम.
सर मेरा क्वेश्चन ये जो लास्ट असाइनमेंट्स है इनसे रिलेटेड है
जी, पूछ लें.
लास्ट की दोनों असाइनमेंट्स का टाइटल असाइनमेंट नंबर 6 है.
हाँ यार, वो मुझसे गलती हुई थी. एक हमने काफी दफा उसको ना उस पे हमने ग्रुप पे डाला था कि जो आखिरी वाली है वो असाइनमेंट 7 है, नॉट असाइनमेंट नंबर 6.
ओके,
ये मैं
सर ये जो असाइनमेंट नंबर 6 है इसके समझ नहीं आई आपकी करना क्या है.
असाइनमेंट नंबर 6 में HEC वाली जो है,
बेसिकली सर उसमें एक रिक्वायरमेंट या प्रॉब्लम स्टेटमेंट नहीं दी हुई, वो सिर्फ एक ऐड है, उसी के अंदर से आपको निकाल सकते हैं.
उसमें सर कोई प्रॉब्लम स्टेटमेंट नहीं है. अगर काइंडली
मैं उसको थोड़ा सा असिस्ट कर देता हूँ. अच्छा चले, मैं इसको ना इसको डिफाइन कर दूंगा आपके लिए ना. मैं जस्ट आपको ये दिखा दूं जो मैं आज डिस्कस भी कर रहा था, जो कि मैं एग्जाम में डेफिनेटली इस तरह का सवाल दूंगा, विच विल बी रिलेटिंग टू दी ई वोटिंग यूजिंग ब्लॉकचेन टेक्नोलॉजी. ठीक है, कि किस तरह से हम डिज़ाइन कर सकते हैं. एंड आई ट्राई टू जस्ट क्राफ्ट दिस प्रॉब्लम स्टेटमेंट कि हम पाकिस्तान में ब्लॉकचेन टेक्नोलॉजी को यूज़ कर सकें. एंड वे अ पर्सन हैज़ टू गो टू द पोलिंग स्टेशन, टू द पोलिंग बूथ, and then he presents himself, and then his vote is to be casted, and then उसी वक्त रिजल्ट आपके डायनेमिकली आपको पता लग रहा हो कि 12 बजे क्या रिजल्ट चल रहे हैं. ओके, यू मे नॉट वांट टू रिवील इट टू.
ओके सर, और ये असाइनमेंट 6 है सर, इसको अगर आगे कर दें.
इसको हमने अगले हफ्ते कर दिया है. दिस विल बी एंड ऑफ द नेक्स्ट वीक, एंड आई विल पुट अ प्रॉब्लम स्टेटमेंट एज वेल. मेरे दिमाग में था डिग्री इसकी वेरी. जी जी,
उसकी डेट
प्रॉब्लम जो असाइनमेंट 6 एंड 7 की मैं कह रहा हूँ नेक्स्ट वीक हम कर देते हैं. ठीक है, और उसको मैं एक दफा देके I'll give you the problem statement as well. I add the problem statement as well. सही है सर?
ओके सर, थैंक यू.
ओके जी.
और सर ये जो हमारा फाइनल एग्जाम है, काइंडली इसमें भी रिक्वेस्ट है.
जी जी जी.
लाइक माय स्टूडेंट्स के इसको ऑनलाइन जो है हम करते हैं. वी आर डिस्टेंस लर्निंग स्टूडेंट्स सर, तो काफी टाइम हमें जो है.
चले, ये मैं देख लेता हूँ. मैं जिस तरह मैंने कहा कि आई वुड प्रेफर पीपल इन पिंडी इस्लामाबाद टू कम टू द कैंपस एंड सिट्स हियर, सो दैट हमारे लिए ना एक मैनेजमेंट का बड़ा मसला बन जाता है. सो दैट एटलीस्ट मैक्सिमम पेपर्स अगर हमें वहाँ पे मिल जाएं इन राइटिंग, एंड देन इफ समबडी इज आउटसाइड द सिटी, सो उनके लिए हम देख सकते हैं कि किस तरह से हम उसको करेंगे. Then I may have to make 2 different papers. One is those who are coming to the campus, and for those who are not coming to the campus will be a little different. सही है? Easy होगा जो जो इधर आएंगे, जाहिर है उनका आसान होगा. थोड़ा सा उनका मुश्किल होगा क्योंकि वो थोड़ा पर्सनलाइज होगा उसके. जी
जो कैंप आएंगे उनके लिए तो इजी.
जी, उनके लिए आसान होगा जो कैंपस में आएंगे. जो कैंपस में आएंगे उनके लिए आसान होगा, जो नहीं आएंगे वो, मैं आई एम नॉट सेइंग कि मुश्किल होगा, वो थोड़ा सा पर्सनलाइज होगा. यानी कि उसमें आई ट्राई टू मेक श्योर कि आप 2 लोग इकट्ठे बैठ के नहीं करें उसको. एंड वी मे नीड टू पुट इट ऑनलाइन एज वेल. ऑनलाइन भी करें शायद हम उसको कि सो यू नीड टू टर्न ऑन योर कैमरा टू मेक श्योर दैट actually you are solving the paper, so to be fair with the other people. तो हम जी बताएं.
सर जिस तरह आपने मिड टर्म में कुछ क्वेश्चन दिए हैं, सो जस्ट के लिए इसको क्या अपडेट है फाइनल का सर क्लियर करेंगे आप?
जी जी, मैं करूंगा, बिल्कुल करूंगा. मैं अभी आपको कुछ क्वेश्चंस दूंगा बना के, so that you can just practice and to prepare for the exam. ये बिल्कुल करूंगा मैं. ठीक है? जी जी प्लीज.
सर वो इन्होंने सुविधा के एग्जाम में मिड टर्म के एग्जाम में जो है वो 2 टीएस के पेपर चेक किए थे, तो एक सर उमर ने चेक किया था और एक सर अहमद ने चेक किया था। तो वो सर अहमद ने तो जो बाद में हमने भेजे थे क्वेश्चन वो उन्होंने चेक किए थे, लेकिन सर उमर ने वो नहीं चेक किए, तो वो उसकी वजह से मार्क्स में काफी ज्यादा डिफरेंस आ रहा है। तो
देखिए मैं आपको बताता हूँ, मैंने उनको बोला है कि जो लोगों ने पेपर जमा कराया था इन 1.5 आवर, वो प्राइम आपका पेपर है, ठीक है। एंड आई टोल्ड यू इन द क्लास एज वेल, उसको नहीं पता था, मैंने कहा था व्हाट यू सॉल्व इन 1.5 आवर दैट इज योर प्राइम पेपर, एंड देन द टाइम यू टुक टू सॉल्व इट आफ्टरवर्ड, के गए आपने 1 दिन में 2 दिन में सॉल्व किया, उनके अलग अलग मार्क्स होंगे और आई विल डिसाइड कि किसको क्या परसेंटेज देनी है। अगर किसी का दूसरा वाला चेक नहीं हो, आई विल मेक श्योर कि वो चेक हो, लेकिन जो प्राइम टेस्ट था ना आपका, वो 1.5 आवर में था जो कि आपने किया है, ठीक है। उसको मैंने टी को भी बोला था कि आई वांट कि 2 डिफरेंट लिस्ट। जी वो मैं देख लेता हूँ उसको। अब अगर आप मुझे बाकी जितने लोगों के थे वो कंसर्न, वो मैंने उसको टीए से मेक श्योर किया था कि वो सारे रिजॉल्व हो जाएं उनके साथ मिलकर। अगर आपका अभी तक कंसर्न है, जस्ट लेट मी नो एंड आई विल मेक श्योर कि इट गेट्स रिजॉल्व, ठीक है। सो अब इस जी
जी तो सर मेरा वो जो प्राइम वाला था ना, वो भी अभी तक चेक होगा।
चलिए आप मुझे मैसेज कर दें, मैं आई लुक इनटू इट। असल में ना दैट इज द रीजन आई डोंट वांट पीपल टू डिस्टेंस में। ये होता है कि वो कहता है मैंने भेजा था, वो कहता है मेरा ये चेक। इफ यू कम हियर इन कैंपस बहुत आसान हो जाता है, बिकॉज वी जस्ट हैव इट फिजिकली, हमारे पास चीज़ें आ जाती हैं। तो मैं अगेन रिक्वेस्ट करूंगा एवरीबडी हु इज इन पिंडी इस्लामाबाद शुड कम टू द कैंपस एंड अपीयर, एंड दोज हु आर नॉट कमिंग सो देयर विल बी अ लिटिल, जो पेपर होगा वो थोड़ा सा चेंज होगा, और उधर आपको थोड़ा सा अपना कैमरा भी ऑन कर रखना पड़ेगा, जस्ट फॉर अस टू चेक वेदर
कैंपस में आके देने का कोई और एडिट बेनिफिट है?
नहीं यार, मैं कुछ खिला सकता हूँ आपको। जी जी
एसओपीज बनाई जाए तो मेरे ख्याल में डिस्टेंस पेपर दिया जा सकता है।
जी दिया जा सकता है, या यार हम बिल्कुल दे सकते हैं, लेकिन हम अगर बिल्कुल ऑनेस्ट होना, मसला ये है कि हमारे साथ ना हम लोग कुछ ना कुछ चक्कर चला जाते हैं। सो इफ वी आर जस्ट ऑनेस्ट तो फिर तो कोई इशू नहीं।
आप ग्रुप में ओपन करते हैं तो वो इतना फ्लड आ जाता है।
जी बिल्कुल।
तो ओपन अप है इस वजह से।
जी मैं ग्रुप ओपन अप कर देता हूँ, लेकिन जस्ट बी डिसेंट। वो एकदम से लोग जो है ना वो जी बताएं।
सर वैसे भी ये ओपन बुक है ना, तो हम घर से जरा आसानी से कर लेते हैं, तो आने जाने में भी काफी इशू हो जाता है।
नहीं, I have said those who want to come here, they should come to the campus. Those who are not coming, just let me know. ठीक है ना, हम जो ऑनलाइन लेना चाहते हैं वो हमें बता दें, जो कैंपस आके देना चाहते हैं वो बता दें। उधर भी, यहाँ पे भी रिलैक्स इन्वायरमेंट होगा, ओपन बुक ओपन नोट्स है, यू जस्ट एंजॉय सॉल्विंग दैट पेपर इंस्टेड, डोंट वरी अबाउट योर ग्रेड्स, ठीक है। सब लोगों को भी ए मिल सकता है और सब लोगों को बी भी मिल सकता है। सो जी
सर
जी बताएं।
सर एक क्वेश्चन था आपसे कि जो आपने पहले डिस्क्राइब किया था कि पेपर सॉल्व करने का ये तरीका है कि सीरीज में आप सॉल्व कर लें, जो आपने उस टाइम रन टाइम 1.5 आवर में करना है, और फिर जो आपको एडवांस टाइम मिलेगा उसमें बाकी सॉल्व करना, आप रिवर्स नहीं जा सकते। तो मैंने सेकंड क्वेश्चन से आगे अटेम्प्ट नहीं किया, तो मुझे पता होगा कि क्वेश्चन चेक होने हैं तो मैं वो अटेम्प्ट कर लेती, आगे वाला नहीं छोड़ देती। सीरीज में अटेम्प्ट किया उसके लिए
चलें, ये आपका ना बड़ा वो एक वैसा पर्सनल सा इशू है, लेकिन एवरीबॉडी अंडरस्टूड करेक्टली कि मैंने कहा था कि आप सीरीज में करते जाएं, ताकि मेरे लिए उसको स्केल करना आसान हो ना, कि वेयर आई वांट टू पुट अ लाइन। अदरवाइज तो होता है ना, कोई आसान वाला पार्ट नीचे से आपने पहले कर लिया, उसके ज़्यादा नंबर हैं। तो टू बी फेयर विद एवरीबॉडी, आई वांटेड पीपल टू सॉल्व इट इन अ सीक्वेंस, क्वेश्चन 1 2 3 4। उस सीक्वेंस में कोई ज़्यादा कर लेता है तो वो उसकी एबिलिटी है, लेकिन अगर वो पहला करने के बाद 5वां कर रहा है, विच इज़ एन ईजियर क्वेश्चन, और किसी बेचारे ने दूसरा अटेम्प्ट किया है, तो वो फेयरनेस नहीं रहती उसमें ना। तो इसलिए मैंने कहा था कि सब लोग सीक्वेंस में अटेंड करेंगे, सो दैट यू बेसिकली फेस द सेम लेवल ऑफ डिफिकल्टी। बट लेट्स मुझे आप पर्सनली वो
सर एक और चीज आपसे पूछनी थी।
जी
सर ये जो बोनस टाइम था, अगर जो हम घर में सॉल्व कर रहे हैं उनके लिए स्टिल बोनस टाइम होगा, क्योंकि मैंने पिछली दफा ना उस टाइम जो सॉल्व नहीं हुए थे मैंने बाद में सॉल्व करके आई एंजॉयड द क्वेश्चंस, सो आई विश कि दोबारा हमें मिले टाइम।
ओके अगर देखें बेचारे वो 3 घंटे से भी मसलन 3 आवर्स, मुझे कोई मसला नहीं है, मैंने 2-2 दिन के भी पेपर दिए हुए हैं, तो इट्स अप टू यू वेदर यू वांट टू हैंड, बिकॉज और भी एग्जाम हो रहे होंगे। 3 घंटे इज एनफ, बस 3 आवर्स, yeah that's what I'm saying, 3 hours just we'll हम 3 घंटे में कोशिश करेंगे कि एक सेंट्रल क्वेश्चन होगा जो कि डिज़ाइन वाला क्वेश्चन होगा, बाकी छोटे छोटे क्वेश्चन होंगे विच इज स्प्रेड ऑल ओवर द कोर्स जस्ट टू चेक योर अंडरस्टैंडिंग। सो इस तरह से, और दे मे बी 2 डिज़ाइन क्वेश्चंस, वन इज परमिशनलेस वाला थोड़ा सा एंड द अदर वन इज फॉर द परमिशन, और MCQs टाइप होंगे छोटे छोटे से जो जस्ट चेकिंग के। जी जी बताइए।
ये नेसेसरी है कि हम लोग हाथ से ही सॉल्व करें, नहीं हम कंप्यूटर से सॉल्व कर दें?
नहीं, आप टाइप कर लें, मुझे कोई नो प्रॉब्लम, इफ यू वांट टू टाइप इट ऑन योर कंप्यूटर इट इज आल्सो फाइन।
और सर एक और चीज करने के असाइनमेंट 6 में सिर्फ डिजाइन करना है या कोड करना है?
नहीं, कोड कहीं नहीं करना है, जस्ट ओनली नीड टू डिजाइन। कोडिंग का मैंने कोई क्वेश्चन नहीं दिया आपको। ठीक है जी, ठीक है जी। क्या हुआ अब? एक अल्लाह हाफिज़ कौन था? ये यही थे यार, ये जो अब्दुल माजिद साहब है ये वाकई कोर्स ले रहे हैं, वैसे ही आते हैं?
नहीं सर, ये वैसे बाकी
कोर्स में भी है?
सर मैं बड़ा
इधर ओके चले। आप थोड़ी देर में तो थक जाते हो यार, आधे घंटे में कहते हो सर बहुत हो गया।
ये म्यूजिशियन बड़ा अच्छा है सर।
अच्छा ओके, सो जी क्या क्वेश्चन था आपका हसन?
सर जो कैंपस में होगा एग्जाम,
मैंने कहा जो कैंपस में होगा और जो ऑनलाइन होगा दे विल बी द सेम एग्जाम, लेकिन जो दूसरा होगा उसमें थोड़ा सा मैं चेंज करूंगा टू मेक इट पर्सनलाइज एग्जाम। ठीक है, सो दैट यू, जिस तरह से मिड टर्म था ना, उसमें हर बंदे का पेपर आंसर ने डिफरेंट आना था, यू गॉट टू हैव समथिंग इन एवरी क्वेश्चन, जिसने उसको थोड़ा सा पर्सनलाइज कर दिया था। तो यहाँ पे तो मैं सेम दे दूंगा सबको ना, बट उधर मुझे थोड़ी सी कोई चीज़ ऐसी डालनी पड़ेगी जो आपको खुद से, यू गॉट टू डू इट योरसेल्फ एंड विल बी डिफरेंट फॉर एवरी स्टूडेंट। क्वेश्चन उसी तरह का होगा।
सर उसमें आप अपना नाम, नंबर या इस टाइप की कोडिंग में डाल देंगे और सर उसके अंदर लिखना है।
जी 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 जी, तो लेस और कोई जी क्या चीज?
एक चीज है सिर्फ कि सर वो आप पर्सनलाइज तो करवा देते हैं, लेकिन एक मेरा माइंड ब्लॉक हो जाता है सर। मैं ये चाह रहा था कि उस टाइम के अंदर कोई कैलकुलेशंस ऐसी ना हो कि बाइनरी की जो कर ना पाए, आप सिर्फ वो सिस्टमेटिक चेक हो उसके ऊपर डिजाइन हो, मतलब अगर वो बाइनरी कैलकुलेशन में कोई एरर आ भी रहा है
चले वो देखिए
कैलकुलेशन में सिस्टमेटिक चेक।
हाँ नहीं, वो इस तरह
हो गया और आगे क्योंकि
जी वो इस तरह नहीं होगा, लेकिन कि कोई बहुत ज़्यादा कंप्यूटेशन तो होगी नहीं इसमें, बट बिकॉज अभी मैंने बनाया नहीं है तो मैं आपको कह नहीं सकता, लेकिन लेट्स नॉट वरी अबाउट इट, जस्ट या देखो ये ना अभी आई थिंक दे हैव टू डू दिस, मेरे ख्याल में दे शुड डू इट, बिकॉज आप देखिए IPPs आपने दिए हुए हैं, इतने सारे लाइसेंसेस दिए हुए हैं आपने, यू नो जस्ट सो एक्सपेंसिव पावर दैट इज कमिंग टू द कंट्री। इफ वी मोटिवेट पीपल टू जस्ट हैव एक मोहल्ला एंड दे हैव दिस लोकल ग्रिड एंड दे आर सेलिंग टू ईच अदर, तो आई डोंट सी एनी प्रॉब्लम, बट आई डेफिनेटली आई टॉक टू, मैंने ये नेपरा जाना है, ही इज़ माई फ्रेंड जो कि उनके चेयरमैन हैं, सो आई वुड गो एंड प्रेजेंट इट टू हिम कि भाई इसको देखें आप, कि हम अगर, बिकॉज सारी दुनिया इस तरफ जा रही है, लेट्स डू एटलीस्ट फ्यू पायलट्स एंड कुछ पायलट करते हैं. मसलन मुझे ये लगता है कि लेट्स से डू अ पायलट इन DHA फॉर एग्जांपल और इन बहरिया और अ न्यू हाउसिंग सोसाइटी दैट इज कमिंग अप. लेट्स डू अ पायलट देयर. लेट्स पुट स्मार्ट मीटर्स. लेट्स मेक देम लाइक
जैसे लोग इंटरप्रेटर माइनिंग नेटवर्क बनाएंगे जिस पर लोग इन्वेस्ट करते हैं उनके पास.
यस,
ग्रिड भी बना सकता है.
बिल्कुल बना सकता है. मैं वही तो कह रहा हूँ. दिस इज देखिए इसका तो फायदा है ना.
आपको जरा आपसे कि आप इन्फ्लुएंसर भी रहे, आप सर ये करिकुलर इंजीनियरिंग इलेक्ट्रिकल का फिर साइंसेस का जो मैंने यहाँ गैप देखा है ना पावर सेक्टर के अंदर मैं जॉब कर रहा हूँ बड़े अरसे से. यहाँ बड़ा गैप है. आप जिस चीज के बारे में बात करते रहेंगे कंप्यूटर साइंसेस का क्या काम है और इलेक्ट्रिकल इंजीनियरिंग का क्या काम है. यहाँ क्या होता है कि कंप्यूटर इंजीनियर्स जो है वो यहाँ बेस्ट सुटेबल है कि उन्हें इलेक्ट्रिक पावर का भी कंसेप्ट होता है, साथ साइंसेस का भी कुछ कंसेप्ट होता है. वो ब्रिज बन रहे होते हैं. हमारे यहाँ है क्या पावर सेक्टर में कंप्यूटर साइंसेस वालों कंप्यूटर इंजीनियर्स को कंप्यूटर साइंसेस की तरह ट्रीट किया जाता है कि बस वो जी वेब या सिर्फ वेब लिंक ही बना सकते हैं और कॉम्बो बॉक्सेस बना सकते हैं और पावर का पता नहीं है. इलेक्ट्रिकल वाले कहेंगे हमें तो जी कुछ पता ही नहीं है कंप्यूटिंग क्या होती है. तो वो ये गैप बना हुआ है जिसकी वजह से ये स्मार्ट चीजें आ नहीं पा रही सिस्टम के अंदर. इसके लिए कोई करना चाहिए यूनिवर्सिटीज को कि ये गैप जो है खत्म किया जाए. जैसे आप इलेक्ट्रिकल प्लस कंप्यूटर इंजीनियर और आप इसमें बड़ा रोल भी अदा कर सकते हैं. आपकी मैंने काफी पोस्ट भी पढ़ी है इस बारे में.
अच्छा चले ठीक है. वो लोग
ना करो यार.
ओके सारे गुस्सा निकाल रहे हैं अपना. नहीं ठीक है. आई थिंक कि इसमें शायद परहैप्स यू आर राइट कि कंप्यूटर इंजीनियरिंग या इलेक्ट्रिकल इंजीनियरिंग मुझे तो ऑलमोस्ट एवरीथिंग अभी इतना ज़्यादा ना डिफ्यूजन हो गई है ना. देयर इज उस तरह से बाउंड्रीज रही नहीं है. दे आर पीपल डूइंग कंप्यूटर साइंस और वो चिप डिज़ाइनिंग वगैरह पढ़ रहे हैं बाहर. सो बहुत ज़्यादा डिफ्यूजन हुई हुई है इस वक्त ना. So and that's why I opened this course for everybody because a lot of management is involved, electrical engineering, computer engineering, and you know. So मेरे ख्याल में ये जो आखिरी जो टॉपिक है माइक्रो ग्रिड वाला, and I think it's something very interesting. ठीक है. और it has value like instead of investing like somebody keeps saying कि जी माइनिंग सिखा दें, उसका कोई फ़ायदा नहीं है. यू जस्ट वेस्टिंग इलेक्ट्रिसिटी एंड पता नहीं आप. बट इसका फ़ायदा है लाइक इफ़ यू इन्वेस्ट हियर इट डेफिनेटली हैज़ वैल्यू बिकॉज यू आर क्रिएटिंग वैल्यू इन द सोसाइटी, यू आर क्रिएटिंग वैल्यू इन द सिस्टम एंड यू आर यूजिंग वट यू हैव लर्न. जैसा मैंने कहा ओपन सोर्स का वो कोड भी पड़ा हुआ है. जस्ट डाउनलोड दैट कोड एंड सी के वो you should able to understand कि आपको सागे. और you can just make your own saying कि अगर मोहल्ला है तो you may just want to make a permission blockchain. ठीक है ना. और कि ना आप इतने बड़े उस पर फैलें, छोटा सा सिस्टम बना लें. लोगों ने ज़्यादा इथीरियम वगैरह को यूज़ किया हुआ है इसमें. सही है. कुछ लोगों ने जो किया है इथीरियम. फिर जब ये ओपन फाउंडेशन आ गया है दे हैव देयर ओन टोकन, देयर ओन करेंसी. बट दे से कि यू कैन जस्ट रिप्लेस द करेंसी विद एनी अदर करेंसी. मे बी योर ओन रुपीज़, you can replace it with your own rupees. Definitely वो पेग होगा अगेंस्ट जिस तरह एक स्टेबल कॉइन होगा जो कि ₹1 का एक कॉइन होगा. तो उस तरह से आप करेंगे उसको. तो ठीक है जी. थैंक यू वेरी मच. इफ there are other questions, no more questions.
The last question.
जी जी प्लीज.
Should we worry about final grades in this subject?
Yes. Abdul Majid.
Sir, I'm very important person, please.
नहीं, don't worry about your grades. Just learn करना. देखें if you have learned in this course then you should be happy. ठीक है. लेकिन क्योंकि ये कोर्स पहली दफ़ा हमने किया था, I would try to give you like good grades, but still there has to be a distinction. People who have spent more time and spend more energy, it will not be fair to them that everybody gets the same grade. सही है ना. So the grading basically gives you कि भाई हमने ज़्यादा मेहनत की थी, हमारा अच्छा ग्रेड आया है, जिन्होंने कम मेहनत की है. So बहुत ज़्यादा ग्रेड की वेरिएशन नहीं हो, but definitely there will be grades because that should demonstrate कि how good people have learned. Especially अभी तो 60% grade decide ही नहीं हुआ है. Still the final is there and then the paper which you have to present. That 20 absolute marks हैं उसके. ठीक है. तो वो एक बहुत सिग्निफिकेंट पार्ट है इस कोर्स का विच इज जस्ट देयर. जी जी.
असाइनमेंट की
असाइनमेंट के 20 मार्क्स हैं, ठीक है. सो एवरी असाइनमेंट हैज 3 मार्क्स बट पेपर हैज 20 मार्क्स. सो यू कैन जस्ट इमेजिन दैट पेपर हैज 20 मार्क्स which is equal to all the assignments.
सर ये पेपर की प्रेजेंटेशन कब, क्या टाइमिंग है?
एग्जाम के 1 हफ्ते बाद. पेपर हैं 2 हफ्ते बाद कर रहे हैं.
एग्जाम के 1 हफ्ते बाद तो हमारा नेक्स्ट एग्जाम है.
2 weeks after the exam. जी 2 हफ्ते बाद, 2 weeks after the exam. It is a group paper, like 3-4 people can work together. ठीक है. So 3-4 लोग जो हैं वो काम कर लें इसके ऊपर. एंड आई वांट दैट जो आपको उसको कहीं जब 2 हफ्ते बाद आएंगे कहीं सबमिट करा के उसकी सबमिशन का बताना है आपने कि इन विच कॉन्फ्रेंस हैव यू सबमिटेड द पेपर. ठीक है जी.
सर असाइनमेंट के सॉल्यूशन मिल सकते हैं जैसे हम स्टूडेंट हैं जिन्होंने ऑडिट कोर्स किया है?
जी मैं असाइनमेंट के सोल्यूशन हम आपको इंशाल्लाह दे देते हैं. दे मे बी द सोल्यूशन डन बाय अ स्टूडेंट. ठीक है. जिसने सही तरह से उसको किया हुआ है ना वो हम उसके ऊपर डाल देंगे ग्रुप के ऊपर. ठीक है ना. सो दैट यू हैव अ सोल्यूशन एंड दैट सेशनल का सोल्यूशन भी हम जिन स्टूडेंट्स ने सही किया ना उनके क्वेश्चन को आपको डाल देंगे एज अ सोल्यूशन. ठीक है. अ क्वेश्चन मे बी जस्ट जी जी
सर जो हम लोगों ने पेपर बनाया था हम लोगों ने एसीएम का टेम्पलेट उठाया था आईसीबीसी में से, तो उसको हमने आपसे रिव्यू करवाना क्योंकि ब्लॉकचेन वाली ईमेल पे भेजते हैं तो कोई फास्ट रिव्यूज नहीं आते.
नहीं आप मुझे उस पर मुझे व्हाट्सएप करें. इफ यू हैव अगर आपने कोई पेपर मुझसे रिव्यू कराना है ना सेंड मी ऑन माई SM जो है व्हाट्सएप के ऊपर ना नंबर के ऊपर मुझे भेज दीजिएगा.
ठीक है सर.
ठीक है जी. सो लंबी क्लास हुई विदाउट अ ब्रेक. सो बट आई थिंक आपको जो पसंद आए. देखें हमने इतनी डोमेन डिस्कस की. वोटिंग वाला जैसा आप कह रहे थे आप रहे हैं तो आई वुड आस्क यू कि आप उसके ऊपर बनाएं पाकिस्तान के लिए. वो बहुत सारी कॉन्फ्रेंस के मैंने लिंक शेयर किए थे और आई सेड के कोई कॉन्फ्रेंस पकड़ ले. यू मे नॉट इवन गो एंड प्रेजेंट. वैसे तो अभी कुछ लोग प्रेजेंट भी कर चुके हैं हमारे कोर्स में से ना यहाँ पे. तो आजकल सारा ऑनलाइन है प्रेजेंटेशन. यू मे हैव टू स्पेंड लिटिल मनी बट लेकिन आपकी एक पब्लिकेशन हो जाती है. सही है ना. तो आप उसको 3-4 सफ़ों का पेपर होता है वो आमतौर पे 5 मैक्सिमम 5 पेजेस एंड जस्ट द डिज़ाइन कि ये आपने प्रॉब्लम लिया ये आपका डिज़ाइन है ये प्रॉब्लम स्टेटमेंट है और उसमें थोड़ा सा लिटरेचर रिव्यू कर लें आप.
कॉन्फ्रेंस वाला पार्ट अंदर से स्किप करें और हम पेपर कहीं से 4-5 उठा के हम अपनी कोई अंडरस्टैंडिंग करके या लॉजिक को प्रेजेंट कर दें वो इनफ हो गया चल जाएगा.
वो एनफ होगा लेकिन मेरे ख्याल में ना आप किसी प्रॉब्लम का डिज़ाइन करें.
डिजाइन करें.
हाँ तो वो छाप दें वो पेपर पब्लिश हो जाता है. कुछ भी नहीं होता. पब्लिश ना कराएं आप जस्ट सबमिट करा दें ताकि थोड़ा सा आपको एक रिव्यू मिल जाएगा किसी और का ना. फ्री ऑफ कॉस्ट यू गेट अ रिव्यू बाय समबडी पढ़ के. तो बहुत आसान है कुछ भी नहीं होता. I'll guide you if there is any issue. It's very easy. एक रीज़न ये भी है कि लोग थोड़ा सा रिसर्च की तरफ आए उन्हें पता हो कि हाउ यू राइट अ पेपर सबमिट इट इनटू बिकॉज द मास्टर्स ग्रेजुएट लेवल कोर्स. तो अगर हर एक को इस एक्सपीरियंस से ही गुजर जाए ना तो दैट इज इवन मोर देन एनफ.
अगर आपके पास कोई रिकॉर्डिंग सेशन हो पेपर सबमिशन या वॉलंटरी या आप कोई आ सके हमें तो रिकॉर्डेड सेशन हो पुराना केस का कि पेपर कैसे सबमिट करवाना है क्या करना है
जी
तो वो इजी हो जाएगा.
जी मेरे पास होगा मैं देखता हूँ अगर कोई रिकॉर्डेड होगा ये रिसर्च मेथोडोलॉजी में हम करते हैं. और अदरवाइज आई मे रन अ 10-15-20 मिनट सेशन टीम्स पे मैं कहीं डाल दूंगा कि हाउ टू राइट अ पेपर एंड हाउ टू सबमिट इट इन अ कॉन्फ्रेंस. मैं ये कर लूंगा सर. आई डू दैट.
सर
जी
थैंक यू सर.
सर सूडो कोड तक इनफ है डिजाइन?
हाँ सूडो कोड तक एनफ है जी डिजाइन.
ठीक है सर.
स्मार्ट ग्रेड का देख लीजिएगा मेरा ख्याल तो इंक्लूड कर लेते हैं. हाँ थोड़ा सा आगे. ठीक है जी. थैंक यू जी. थैंक यू वेरी मच. अस्सलाम वालेकुम.